Right, let's just begin. Oh, God, I feel alcohol squashed up there as well. Hang on. Oh my God, what is going on here? Let me copy this from. Oh, that is copied from somewhere else. All right, fair enough. I look really tall for some reason. I don't know why. Nudge that up slightly. There we go. Hopefully, you can hear me, guys. Happy Saturday. Praise be the spiral. Um, Icon Star Hero C here. Oh, is this about supremacy? It's almost certainly going to be. Yeah, thought so. Yeah, I'm not doing that now. Somebody's already done that, so I'm just gonna knock the music volume down slightly. There we go. Somebody's already done it, so I'm not going to do it. I've kind of losing the will to live with Commodore stuff as well at the moment. So I'm trying to do stuff that I find kind of exciting and just leave it at that. Okay, I just need to test my picture in picture to make sure. Okay, I'm different on that one. Okay, let me just copy that because I look better on that one. To remove that and paste that one on. Here we go. I'm a little bit squashed, but it's fine. Don't think I'll be here for long. I feel really awful. Oh no, that's not good. I hope you feel better soon, SP. Um, okay, so what we're going to do tonight, we're going to do something different. So, Pick Mix I consider complete in terms of the stream. I don't think there's anything I can really add on the stream that's going to make for interesting watching. It's really just going to be tying everything together now and getting it out the door. I'm kind of over it now as well. I've spent 2 years making that thing on stream, and I'm sick of the sight of it. I just want to get it out. So just gonna give it a couple of weeks of rest where I don't do anything with it, and then I'm going to jump back on it probably the end of or the middle of next month just to not on stream, off stream. Jump back onto it in the middle of next month just to tidy it up and get it out the door. I'll probably do one more stream with that game, but it will be like probably on a Tuesday, and it will just be playing the game multiplayer. So we're just going to set a match up, set a virtual private LAN up, um, and just do some stuff on that, just playing it together and see how it goes. You know, you guys take it in turns, play against me or something. I'll figure out exactly how that's going to work close to the time. But for now, just bear in mind that the Let's Make a Game stream is pretty much complete now. So we're going to move on to doing Mega65 on Saturdays now. So we're going to start tonight a little bit simple. We're just going to do a kind of random grab bag of stuff on the Mega65. The only thing I know for certain is that we're going to go through Luma and how I converted that from C64 to Mega65 to hopefully kind of give you an idea of how easy that is to do so that when you do get bigger, what do you mean bigger? I've not even opened anything yet. I've not even opened anything yet. There is no text here. There you go. Happy? I put some text on the screen for you as well. Um, yeah, so that's what we're going to do tonight. Once we've gone through the Luma stuff, I'll answer a few questions that anybody's got relating to Mega65. I'll do my best to answer it. One thing I've realized a lot over the past 3 weeks or so is that the emulator is incredibly difficult to correlate with what's happening on the real hardware. There are so many things that just aren't working properly on there yet, um, or don't behave exactly the same way. That there is a lot of time wasted trying to kind of sort that out. So I've said to myself personally, I'm not going to touch the I'm not going to touch the emulator now on stream. It's just too frustrating and it's too much of a time waste for me to try and explain anything. Um, Too slow, Andy. But the right background just too slow. It's too much of an effort for me to try and explain things when I can't know for sure. I don't use the emulator for this reason. It's easier for me to just upload it to the real machine, and then at least then I know what I'm getting is accurate. Now, um, done a Mega65 team, got people to explain those things. It's kind of difficult actually. The team is very busy with lots and lots of different things. The best thing you can really do when when you've got a problem is check with somebody who does have a dev kit, myself or one of the other people, um, and first of all, find out if that is the correct behavior. If it's not the correct behavior, then jump over to the Mega65 Discord and have a word with LGB or Hanand P. I think Amok's been doing this quite a bit, and they'll be very happy to help you and kind of make you understand those things. But you've got to realize that there is a lot going on. And there's a lot of little things changing on the machine that LGB and Hanan need to keep up with. And at the same time, they're getting the stuff coming from us as well. So you've got to be you've got to be expectant that these things may not get sorted out straight away. However, yeah, as Paul says there, LGB will respond to you very quickly. So although it may not immediately get fixed, but you can kind of rest assured that any concerns you do have with the emulator will get documented somewhere. I think there is a GitHub where you can drop issues in as well, but it's always worth chatting to somebody with the dev kit first, just to guarantee, is it a dev kit thing, is it an emulator thing, and then go and check with LGB just to make sure it's not something that they're already aware of and that they've got a ticket for, and then yeah, if all of that is not okay, then you can add a ticket yourself to explain these things. However, saying that, um, that's not to say that you shouldn't be using the emulator. The emulator needs people to use it. That's why I run these competitions. I want people to use it, to report these things, and you can do some very good stuff with it. I've already had 2 entries into the competition sent to me already. I know there's at least 2 or 3 more coming this week. Um, so it can definitely be done. It can definitely be done. I realize that you do have to persevere a little bit. Um, and I appreciate that. But as I say, the reason I'm not going to go through the emulate stuff on stream is just because for me personally, I don't use the emulator at all. I use the device directly, so I would be wasting my time and your time trying to explain something that I don't really understand properly. And we had a stream like that a couple of weeks ago, and it was a disaster. So I'm going to avoid doing that. Um, that's just my personal opinion to what makes a good stream or not. That doesn't mean you shouldn't be using it. I mean, obviously, you don't really have much choice in the matter, but it's yeah, exactly, Eldritch. It is a new wild frontier. Emulators are not going to be up to scratch for a while. Um, the Mega65 is an evolving machine still at this point. It's evolving less than it used to, but it is still evolving. So it's an impossibility to expect the emulator to be on a par. And I do hear people in other groups and commenting about whether or not the Mega65 is worth getting or not, complaining about the emulator. And I just think to myself, how can you complain about an emulator for a system that doesn't even fully know what it is yet? There's a good idea of what the system is going to be, but things are changing all the time. You can't expect everything to be there from day one. It took years before we got Nintendo 64 emulators, or all these various, there was lots of things that come out and take years before we get emulators. I challenge you, go and find a PS4 emulator, go and find an Xbox Series X emulator, find a PS5 emulator. You won't, because they don't exist yet, because they take some kind of reverse engineering tasks, and they take extra power to do it. And with the Mega65, we've got 40 times the power and then some, because we've got other things going on like DMA and stuff. Um so yeah, I when I see those comments, it makes me a little bit mad actually, that you can't expect these things to work. You have to work your way around them, and that's what the dev kits are about. They're about giving developers something that they can work with, that is basically the final hardware. So anyway, that's my little soapbox soapbox rant done. But I'll try my best to answer any questions any of you do have regarding what you're working on for the games. But as I say, just beware. I may say it's an emulator thing. You may have to speak with LGB. So um, people need to learn to respect hard work and accept that things aren't perfect. Exactly, the amount of effort that's been put into all sides of this project, is incredible, and the fact that you are able to emulate anything at all is a very, very nice thing indeed. So many projects don't have this early on, so mm, it's just some people just really want to have everything, have the moon on a stick. Anyway, thank you for the host, Andy Magic Knight. Thank you for the host, Prow7. Thank you for the resub as well, 6502 Kebab. Let's give you guys some points and get the hang on, let me just sort out all my windows up here. They're all wrong. That should be off on pause. That should be on that. Also on pause. There we go. All right. Um, how does the 65 compare to say an Amiga 1200 in graphics capabilities? Mega 65 Paul's answered. Sure, it's on a par overall, but better for quite a number of situations. Yes, I would definitely agree. I think overall, it's around about the size. It's around about the power of an A1200. But there are some things that are just far superior on the Mega 65. And yeah, the RRB sprites is one of them. The number of sprites you can throw around the screen and the number of different layering things that you can do, and the amount of colors that you can put on each of those layers far surpasses anything the Amiga was able to do. Um, so yeah, in terms of that, I think it's slightly ahead. I would say the Mega 65 is ahead of the A1200, only just, but it is ahead. RB sprites don't need to be undrawn every frame. It depends how you do them. The way I'm doing it, I do have to undo them, but they can be done. It can be done very, very quickly. So, um, I liken the RRB sprite system. Let me add these points. I liken the RRB sprite system to a multiplexer, in that it has a similar kind of payoff for what I'm trying to do with the layering and all that lot. In terms of um, the amount of raster time you need to dedicate to it to per frame is very similar to what you would do with a sorting algorithm in a multiplexer. Um, there we go. There's some points to you all. Um, except the numbers are much higher. So on a multiplexer, you're kind of looking at going up to maybe 32 sprites on a very very optimal multiplexer with enough room to do that sort. But with the raster rewrite buffer, you're looking at 200 to 300 sprites of huge sizes as well. So. Uh, oh yeah, no, it is just undoing the list. Yeah. Uh, I do actually have to clear I do clear some of the screen data, but that's because I deliberately move things around within those layers. So Great Defender Game Boy Doc release candidate 2 lost two men on the third screen. So frustrating on the third screen. Wow. All right, let me start the races for you guys, and let's answer a couple more chat questions, and then we'll get into that. So, is there any step-by-step documentation on how to implement RRB? I've seen demos of it, but never seen the code that actually implements it. Um, I did a video on it a while back. That contains some kind of explanation about how it works. Doesn't really contain much in the way of code, but it does give you a good idea how it works. And yeah, Paul's Mega Maze has got the source available. Um, am I using it in Luma? No, I'm not using it in Luma. There's also the code that I'm working on at the moment for Perseus. That's the core framework for that is going to be released at some point, and that includes a raster rewrite buffer sprite implementation as well. So, thank you for the hosting. Now, very much appreciated. Skull Monkeys. Oh, I vaguely remember that game. Yeah. Um, But I may do another stream on that at some point. Now Saturdays are now dedicated to Mega65, so we're going to be doing this. Um, we're going to be doing this every Saturday. Tonight, I'm just going to take it a little bit easy. I'm not going to jump straight into some stuff. I don't have a whole lot of new stuff um, for Perseus anyway, so I may do a little bit of it, but I'm not sure. I'm not kind of tying myself to anything just yet. We'll go through the Luma stuff. I'll explain how that was done, and then we'll go from there and see what's left to do. One other thing before we start as well, I got my Sega Nomad uh, finally. So I've been playing through some games. So it came with Sonic 2. Um, which is great, but I've played Sonic 2 to death. I didn't really need to play anymore. So I've got an Everdrive coming, but in the meantime, I also got one of these cartridges. Unfortunately, it's not the best selection of games. It has some great games in there, but they all fit into like one or two categories. So I really wanted like Toe Jam and Earl and stuff on there. So, um, but it's a really cool little system. I don't know if you can see it. Let's see if it. Oh, I need to actually plug it in. So I modded it as well. It came with a battery pack on the back. I've modded it to take power lead in the top here. And the reason I did that was because the power lead here is a bit faulty. It needs a new one. And I don't want to pay $20 or whatever it is to get one shipped from the US, which seems to be the only place I can get those exact ones, when I can just mod the battery pack to do the same thing. So that's what I've done there. But it's really cool. So I've been playing what was I playing? Gunstar Heroes. I played a little bit of Golden Axe, played a little bit of Alien 3 I was playing as well. Um it's very cool. It's a very, very nice system with a really good screen on it as well. Um I've been playing that a little bit and reading up about how to code the 68,000. I've literally spent 10 minutes like skimming through some online tutorials. It seems fairly straightforward. It's just other little things I need to remember about it, but I'm sure once I get cracking with it, I'll be all right, and I'll figure most of the stuff out. So looking forward to doing that. That's probably gonna be Tuesdays that I do those things. I just need to get the kind of basics set up and work out how I'm doing my graphics, work out how I'm doing my sound. My piano practice is going quite well. I'm getting better and better at it, so I'm hoping I should be able to do my own soundtrack by the time I need it. And I'm probably going to do Dot Cosmos 2. Um, so the more and more I've been playing these games on the Mega Drive, the more I've realized is the one thing it's very, very good at is that kind of side scroll shoot 'em up platformer sort of thing. So you games like Alien or Gunstar Heroes or Contra, things like that, work really well on the Mega Drive. It's got the right kind of sprite counts, the right kind of layering and colors and stuff. So I think I'm probably gonna go down the route and just take what I've done for Doc 2 on the Commodore 64 and translate it over to the Mega Drive. That's not to say it will never come out on the Commodore 64, but it's likely going to come out on the Mega Drive first. Um, it's a it's a bit of a shame, but I just kind of losing my way a little bit with the Commodore. I think I've been doing it so much over the past few weeks or months. Actually, I just need to take a small break from it. And by small break, I just mean like not do 3 nights a week on it. The Mega 65 is good because it kind of keeps my 6502 sharp, but gives me a different machine to play around with. And we've got Checknoid on Thursdays as well. So I'm still doing a lot of stuff on there, but I just don't want to kind of dedicate another 2 years to a Commodore game just yet. So um, just put it out on the Amiga. Well, there is that as well. So if I get it done on the Mega Drive, in theory, the code should work fairly similar to the Amiga, right? It's just the rendering code that'd have to be different. So whatever I'm using for drawing the maps would probably have to be rewritten for the Amiga, but and the sprites. But yeah, I mean, it certainly could be done on the Amiga. I'm not a huge fan of messing with kind of Amiga configurations, but um, we'll see anyway. I say settled Megadite. ST confirmed. No, we will not be doing ST. What background's that? Oh, Quark's bar. Hey, did somebody? Oh, you redeemed it. I was hoping someone would guess that one. Uh, it is a fast-scrolling game, yeah. So it's kind of it's similar to Turrican in the way that it scrolls, but with inertia. So Turrican doesn't have inertia on the scroll. At least it doesn't on the Commodore. It might do on the Amiga. Actually, I can't remember. But there's inertia in this, plus parallax and stuff. So it would be it is going to be quite a graphically intensive game, I think. Plus, it needs the ability to switch between character sets on the fly, and also pause and rewind the game as well. So I'm hoping there's enough RAM to do the rewind kind of story stuff, because you need to store positions of the map and the player and enemies and stuff like that. So, which is actually a real tricky thing to do on the Commodore. All right, let's crack on with this then. So as I say, we're going to go through what I did for Luma. So first of all, let me just show you it running. We can pick the right one here because I've got two of these, and then we'll go through the steps that I did to get this to work. And kind of what we can talk about the gotchas, the sort of things that you need to kind of keep an eye out for while you're doing this. The little tricks I had to use to overcome some of the design decisions, because obviously there are some things you can do in the C64 that aren't going to work quite as well on the Mega 65, and that's not because um it's not because your the Mega 65 is limited. It's because of just the difference in modes, and I'll explain some of what I had to change to get this to work. Let me just think. Oh god, that's so tangled. Okay, there we go. There we go. So you can see it's exactly the same game. Let me put it on. It's exactly the same game that we made for the C64. Everything's pretty much the same. The only difference is the graphics have been changed, so they're now using the full color mode graphics. The reason I use full color mode graphics and not the nibble mode graphics is it was just easier for me to implement this. There wasn't really a memory concern, so hey Igors, there wasn't really a memory concern, so using full color mode just made it easy for me to work with. The other thing that's changed, of course, is the hood panel on the side is very different. I drew something. That's the first thing I drew actually was the hood panel. I just wanted to see what I could come up with, and I was actually quite pleased with the results. So I ended up dropping that into the game, and the logo for the game has changed as well. Again, because we've got colors to mess around with. The graphics have just been updated so that they kind of fit more the multicolored style. That the high color count style. So you've got these gradients on the blocks. Before these blocks were circular, now they're just gold kind of bricks. Um, some of the stuff is the same. So the success sprite in the center is exactly the same. That hasn't changed. The cursor is the same as well. That there's really no need for me to redraw this cursor. The only thing that's changed there is the color ramp that it uses. Um, but other than that, most of it remains the same. Um, so let's go through how this works and try and explain to you the kind of obstacles I had to overcome while I did it. Just to put this into perspective, this took probably about between 6 and 8 hours, I'd say, max to do. Not a lot as well. Seeing as it's 16-bit, make the lasers join at the corners. This was a port Gunstar. If this had been written from scratch, then yes, I would have done that. But this was a port, so I didn't change very much of the code at all, which is what I'm going to show you now. The reason it doesn't change at the corners is due to a design choice when we did the C64, and it would have been well, I mean, it could be added in, but it doesn't need to be added in. It's perfectly serviceable as it is. So let's try and explain what I did then. So the first thing obviously I had to do was take a look at the memory map. So this was the memory map originally, and what I wanted to do was try and utilize memory only above 2000. So on the Mega 65, your code starts at is this the Mega 65? Yeah, it is. Okay. Your code, your basic entry point is at 2001 hexadecimal. So 8193 in decimal. So I wanted to make sure everything was above that location. The reason I wanted that to happen is because I didn't want to be loading anything below that point, which would then get corrupted by other things. So the first thing I did was to kind of shift everything up to that by setting a new basic upstart. So in the original code, let me bring the original one up. As you see in the original one here, we have a basic upstart 2, which is the standard kind of C64 basic upstart 2 entry. This creates an entry point at 0801. And you know, from that point on, all code we put in here just gets added there. So the first thing I did was obviously set the CPU to 45 DSO2 and include my new macros that I use, and set this value here. So now all the code starts at 2001. Well, actually, the basic entry is at 2001. The code starts at 2018. So you'll see when I compile this original C64 one, you can see this memory map here, and you can see that we've got a few functions down at the bottom from 0801 up to ODA1 before the music, and then everything else is at 3000 plus. So you notice there's a big gap here between the music and the code here. So that was a good sign. That meant that I could probably squeeze all of this into 2000 um, and still kind of have this code hitting, you know, in the same place. I'm not using any extra locations. So um, hey, Dr. Miz, welcome. Take care, Paul. Thanks for joining. Thanks for answering some questions as well. Very much appreciated. Take care and cheers. So the next thing to do once I had that was to remove the music. So in this version, we have music loaded in. Actually, you don't see it, it's down here somewhere. So Richmond Mike's soundtrack was loaded in here at 1000. So I had to remove that. So because I didn't want anything loading below 2000. So that was removed. And then I went through all the code looking for references to 1000, 1003, 1006. So that is the init, the play, and the sound effect references in there, and just commented them out. So they still, the function still ran, but the you know, the block of code where the music would be called still ran, but it just didn't do anything. It didn't jump into the music code. So those lines were commented out. So in this, so for instance, I would just come in here, I'd look for 1000, and I could see that you know, there's one here, so I would comment this line out. There's another one here, so I'd comment that one out, another one here, so on, and then I do the same for 1003. And that would give me, you know, music commenting out there, and then I do the same for 1006, which would give me the sound effects to comment out. So doing all that would then allow me to run the game without sound, but it should run. And sure enough, if I do that and run the game, it did run. But obviously at that point, everything's just a mess. There's garbage all over the screen. Nothing looks right. I can just about kind of make out that there's a menu system there, but it's just absolute junk. Um, I'll answer that in a second, Doxter. When I get back to the music, I'll explain that. Yeah, because I did investigate doing that, and unfortunately, it wasn't as straightforward. At least I wouldn't have been able to do it as quickly as I did if I'd have gone down that route. Um, so yeah, with the music blanked out, and the game actually running, but not obviously displaying quite correctly, the next step was to implement all the kind of mode stuff that I need for the C65 or the Mega 65. So basically, enable 40 megahertz, enable the VIC4 registers, disable ROM protection, all the basic stuff that we do when we set a Mega 65 program up. So that's this bit here, and these bits here as well. Uh, the next thing I did was then enable full color character mode as well. So this is this is because I wanted to display the characters like that, you know, in full color rather than high res. So what I did in order to do that was turn on the full color character mode and then change my screen RAM pointer. So on the original game, our screen RAM pointer points to, I think it's C00. God, why can't I scroll up? There we go. Yeah, C00. So what I did was just point it to 0800, which is the default area for screen RAM on the Mega 65. So I didn't have to actually move the screen RAM at all. I just setting this up to point to it. Likewise, I changed the color RAM to point to this location. Now this is now a 32-bit. Actually, I mean technically it's a 28-bit, but it's a 32-bit kind of vector to color RAM. So the next job was, and this is the color RAM that's up in the high end of the Mega 65 RAM, and there's 32K of it, so it gives me plenty of room to mess around. Um, as you'll see later on, the only thing I need from the color RAM is to be able to blank it all out so that things display properly on the screen and don't trigger raster rewrites. If you've been doing stuff with the Mega 65 on the emulator over the past couple of weeks, you'll know if you don't clear the color RAM and you're in full color mode, full color character mode, you will get lots and kind of weird artifacts happening because the extended attributes of full color character mode use color RAM to do things like hardware blinking, raster rewrite, go to X's, and stuff like that. So if you don't clear that with zeros, you end up with all sorts of weird stuff going on. So that's why I needed that there. But obviously, changing that meant that what I needed to do now was then go and find all my references to color RAM. And make some oh that's no and yeah, well actually yeah, I commented most of them out to begin with. So I went through commenting out all the color RAM locations, and then I created a new clear screen routine, which I can find somewhere. That's the completion. Clear screen. There we go. Window over text. Ah, good point. Let me. Yeah, there we go. So I created this new clear screen routine, which uses the DMA jobs, which we talked a little bit about last time, to actually fill the screen with a blank character and also clear the color RAM exactly as we need it to be cleared. I also created a routine which imports the palette that I have set up for this. And I'll show you in a minute how I did the graphics for this. So with the palette set up and with the clear screen set up, I could get to the situation where the screen was actually clearing properly. And the colors on the screen were kind of what I wanted them to be, but obviously I still didn't have proper graphics. So the next step, with everything, what was I saying? With everything set up in terms of sprite pointers, which again I hard code to this location. This was just a free location, so this is what I use for the sprite pointers for my screen RAM and my color RAM. With all my color RAM references commented out, my next step was to actually create the graphics. So let me just try and open this up. Hopefully, I can. I'm gonna say it is that one. Yes, it is that one. Okay. So this is the graphics. So I started by I actually started down here and create this. This wasn't in this format. I moved things around a little bit to make everything fit. But I started by making this panel, and my idea was that I wanted to try and create a nice new hood panel for the side, and then see if I could get it to display. So I created this replacement. Everything is in pretty much the same place as it was on the original hood, with the word passcode, author, shifts, and puzzle in exactly the same places. So with gaps to allow the additional text to appear, which you can see, you know, down here. So you can see the code that writes these things hasn't changed. But what changed was the graphics around it. So I did that first, and then when I had that right, I had to then go in and start changing my screen RAM stuff. So one of the things that obviously is very, very different between the C64 and the Mega 65 in full color mode is that every location on the screen takes 2 bytes on the Mega 65 instead of one that you get on the C64. So that meant going through my code, finding all references to screen RAM, and basically adding a ×2 on any calculations for rows. You see here, there's a ×2. So all my tables have a ×2 on the end. This is to make sure that when you point to a row, you're actually getting the rows are 50 bytes long, not 28 byte longs in hexadecimal. So 80 bytes long, not 40. So the ×2 on every screen RAM calculation, and you'll see it all over the place. ×2 here, but also whenever you do anything on the X as well. So you can see there's a calculation for the X position here. I also had to add a ×2 on the end of that as well. So this is something that's kind of time consuming, but it's very easy to make things fit the algorithm. The algorithm is simple. Look for something that uses screen RAM. This is why it's really useful to write your addresses like this when you're doing screen RAM stuff. Treat your X and Y as separate values and add them to the screen RAM address. Then that way, when you look back through it, doing stuff like this, it's easy to do. And yeah, so yeah, it's basically just timesing everything by 2. It's making sure that any offset into the screen RAM is doubled. So I could have done it like this, or what I could have done was just put a thing around this like that and times that whole thing by 2. But it doesn't really matter how you do it. The point is that you need to double the offsets into screen RAM. So going through all of that, I did that. The other thing I did as well was then check anywhere that there was any stepping through the code of screen RAM. So for instance, here there's let's go through the hood, right? So I'd look through the hood and I'd see actually there isn't any in this one. Here we go. Yeah. So whenever the new row would happen, there'd be an add 28. So I could look this up. I could just look up add 28 because this is usually how we advance the screen onto the next row. Those would all need doubling as well. So anytime you advance through the screen references, you also have to advance through there. So um, duh, duh, duh. Sorry, just keeping up with the chat. Yeah, so that was kind of a time-consuming task, but at the end of that, what I got was I actually had a screen that started to resemble things now. So even though it was garbage that I had all over the screen because I still hadn't imported this properly, by changing all those screen references, I actually had recognizable kind of patterns on the screen that would, if I did a move with the sprite, I would see the shift counter would change, so I would see things happen in the right places on the screen. So the next step was to change all the references to characters to use this character set instead. So first of all, I created this hood, and then going into the hood, that was just a matter of uh, changing the hood tables here. So there were 2 tables which would well, actually there was 1 table which was the characters that made up the hood. Um, it looks kind of complicated here, but essentially what this is doing is it's creating a link uh, to these in order, basically. So it's just going through these in order. These are stored up in the higher area of RAM, so they're at 10000 to 1FFFF. And so I just load them in. At first, I was just loading them in directly in the PRG, something you can't do in the emulator at the moment. And then creating these tables to point to them, and then when you go to draw the hood, all it's doing is grabbing those values and storing them on the screen. With that in place, I actually had a hood displaying on the side, so I realized then that this was going to work. So my next job was to try and get everything else on the screen, and this is where it started getting a little bit complicated. just keep up with this. um, yeah, okay. So the next thing, was to get the actual graphics on the screen. So everything else that you see on the screen here is, with the exception of the flashing cursor, everything else on that screen is also characters. So all I needed to do is change the routine that draws these, to basically use new 16-bit values instead of 8-bit values. So first of all, wrong button. First of all, I imported the existing character set into Sprite. So what I did was I in Charpad there's a feature where you can save out the tile set as an image. So I saved out the tile set as an image, and then imported that image into here, so it fit perfectly in this section up here. I then spent about an hour or two just going through and changing all the graphics, so that they were basically, more up to date. So I extended the palette. What I actually did with the palette was I took the Commodore 16+4 palette, which is this first bit here, as a base, and I added a Google Material UI palette onto the end of it as well. I made a couple of adjustments to some of the colors, like some of these reds and things and greens and blues were changed just to accommodate like the laser beams themselves. But generally, the palette is a mix of those two. So Commodore 16+4 palette and the Google Material UI palette mixed together, which is kind of nice. God, that game has come up so many times. I like the fact that it took 1, 2, 3 goes before somebody could spell it. So yeah, I went through the character set, just updating it, basically making it look decent. So I would basically draw it down here first and then import segments up here. You'll notice that the character set is split into red, green, and blue sections, and that's because we were using the color RAM to change the color. But obviously, if you're using full color mode, you can't use the color RAM to change, because the color RAM doesn't have anything to do with the color in this case. In full color mode, it does things like blink and stuff. So you'll see what I'll explain shortly, why these are duplicated in green and blue in these specific places and how that works. But yeah, essentially going through, changing all of these, and then importing that into the map. So this square here is a character. Let me try and write this down here. So that's the first character. That's the second character. These are the 16-bit values for them, and so on. So what that meant is, if you ignore this upper nibble, the lower nibble was exactly the same as it was on the C64. So that's very useful information, because what that means is the routine that clears the screen, as long as it clears the upper nibble to always be 04, then we can use the same routine to draw the lower nibble as we use on the C64, and we'll just get a screen that's built out of this red section of the font. And that was my next step. So by doing that exact thing, changing the clear screen routine to always change the upper nibble to 04, and changing the actual map display, the thing that draws the tiles on the screen, to use the same value as before, but obviously advanced by 2 bytes at a time. I got the full map to display with proper proper graphics. It looked like this, but everything was, any laser you fired would always be red. Anything that had a color. So, for instance, in this case, these uh, these things here, the receptors would always be red. These lasers would always be red. They would always fire red as well. But the point is that it was now working. It was now visually working. So this is where the fun bit came in. So I realized that I couldn't use color RAM to change the color of the lasers, but what I could do is I could treat these screen kind of values. So these are the characters that get drawn on the screen. So I was treating this as the actual character to be drawn. But what I could do is I could treat the upper nibble of each of these screen addresses as a color RAM value. And so this is why these are copied where they are. This green one starts 0500 and this blue one starts at 0600. So now instead of using the colors 2 for red, um, 5 for green, and 6 for blue, what I would now do was use 4, 5, and 6, which would be red, green, and blue, which is red, green, and blue. And I would just be changing the upper nibble instead. So that was a kind of a big revelation for me, because that meant that I could then treat the game exactly as I did before, but now I'm actually using kind of color RAM but interweaved with the screen data. And that's how this works now. So what happens is anytime I would go and have a look at the piece of code that updated the color RAM, I would work out, okay, is this actually necessary anymore? Because some of it was unnecessary. And if it was to do with changing the color of a laser or a laser beam or a receptor, then I would just change the upper nibble for that screen address rather than the single 8-bit value in color RAM. And that gave me the full, the full game basically at that point. So now I had lasers that would work and be the right color. The only problem I then had was there was an issue with lasers that crossed each other. So what happens when a laser crosses in Luma is it changes from one tile to another. So this tile, for instance, if you've got let's draw a tile with some stone in it, and the dots can be the gaps between the stone. But this was a common piece in Luma, right? You'd have a piece like this that had a way through it this way and a way through the top. So if I was to draw a laser through here that was red, and then I wanted to draw a laser down here that was green, those are 3 different tiles. So this is one tile, this is another tile, and this is another tile. Now, in terms of the tiles themselves, they don't care what this color is, right? The tile will always just use whatever it is. It was the color RAM that would define this. But what it meant was that because we were redrawing those tiles, because the tile was changing, if I drew a green laser through and then I wanted a blue laser to come down, what would actually happen is this would turn to red instead of staying as green. And the reason for that is because what would happen is it would go to redraw the tile. So it would redraw this entire tile and it would look like this. And then it would just color the bit that it was interested in. So this new section here, just these 2 pieces. And so we would just get the color for the bit that was added, but not for this bit. So I had to spend quite a little bit of time working through that, and it was a bit complicated to figure out how to do that in the end. So there are little problems like that you will come across, especially if you're using color RAM, especially in the way that we were doing it in Luma. But um, generally, it is a relatively simple thing to kind of set screen and character stuff up. And it really doesn't take that long. This was kind of the bulk of my work was drawing this and working on that last issue. But up to that point, I'd probably only spent, if you take this out of the equation, the drawing of this, I probably only spent about an hour or 2 changing the code. So the other thing that was different was the scroller on the bottom. So on the C64, obviously we use the hardware scroll register to move things along the bottom. On the Mega 65, that's not really in fact, I'm not even sure it works like that properly on the Mega 65. So what you do instead is you use the screen offset, like the draw offset. It basically performs the same task, but what you're telling the Mega 65 is start drawing the border in a different place and start drawing the text in a different place. So you can see I pulled the borders in slightly on each side to emulate the same thing on the C64, and I used the beginning offset to draw the scroller. Essentially, it looks exactly the same, but it's using a slightly different method for it. The other thing as well is there is gradients through all this text as well, which is where the material UI came in really handy. pick a color like this orange, draw that in the bottom line. Actually, it's this one, I think. No, or is it this one? Yeah. And then just work your way up through the palette, adding the gradient in. Same with the blue, right in here as well. I pick a color in the blue and just work my way up through it like that. This is where the material UI palette is really, really useful, actually. And that was pretty much it for the game. The only thing I really had to do after that was the sprites. Because the sprites, there's a couple of sprites in the game. There's not that many. One of them is obviously this cursor that you see moving around. The other one as well, and this is where I did have to make a change, was when you move these objects around, they turn into sprites temporarily so they can be moved. Now on the C64, what I did was I created exact replicas of these items in sprite data, um, which when you're using multicolor sprites on the C64, and multicolor characters as well, it's an easy task to translate multicolor to multicolor, right? But now what I was doing is I was using high res sprites or the C64 sprites. I wasn't going to change the full color sprites, but then I was using these full color characters. So I decided what to do instead was create outline versions of these. So you'll see as I move these around that they turn into outlines. I don't know if you can see that, probably just about. Um, and that was just to kind of get around the fact that I didn't want to have to kind of find a way to redraw everything and do some crazy stuff with the sprite system. I wanted to leave as much of the code intact as possible. So in fact, the only thing I'm doing here is changing the sprite pointers. So again, if I just go and have a look for sprite pointers, you'll see what I did. It's quite simple, really. Okay, sprite pointer maybe. And that's the C64 one. Let's do it in the. No, that wasn't the C64 one. That was the Mega65 one. Yeah, it is the Mega65 one. Okay. So you can see I'm setting up the 16-bit sprite pointers. And you can see all the only difference is whenever we use sprite pointers, we again times by 2 because we're now using 16-bit sprite pointers instead of 8-bit. So anytime I use a sprite pointer, I just times by 2. And then I also have to add the upper byte in. So this is basically your Vic bank here. So just to go back to this overlay again, thank you. So yeah, you can see here. This was the original code. This chunk here, and this would have not had any of these times twos on the end. So it would have just been increasing the y, storing it in these values. This is actually the bouncing success logo thing. That's what this is doing. But in order to make this work with 16-bit sprite pointers, you have to double all of these addresses basically, so that you get the low byte of each sprite pointer, and then you have to do an upper byte, upper byte, sorry, the most significant byte here. So you do again times by 2, but plus 1, and then this value, this 3 here, is just kind of which bank of memory it's in. So which 16 kilobyte bank is it in? And the sprites stayed in the same place in memory, which was in the upper bank at C0 onwards. And so by setting the upper byte of the sprite point to 0, 3, we're pointing to exactly the same place again. So I didn't have to change the sprites in terms of their locations or their sprite numbers or anything. Those stayed the same. I just had to point to them slightly differently. And that's what that was doing there. Same goes for the control. It's exactly the same method. This was the original piece of code. This wasn't there, and that wasn't there. Oops, like that. So it was just storing. It was storing whatever value we'd got from here into the sprite pointer. So all I did to change this was times it by 2 to store it in the correct point, because we're now 16-bit sprite pointers, and then make sure I store 3 in the upper MSB of that as well. I had to use the stack just to make sure that we restored the accumulator, because it is used down here as well. So I always just keep an eye on whether or not the value that you've used here is being reused further on, which it was here. So again, on the second one, it's adding 1 to this initial value here, and then putting that in pointer plus 3. which again I times by 2 to get the 16-bit offset instead, and I put the 03, in other words, the Vic Bank number, um, into the upper nibble. That simple, and that gave me all the sprites. So really, all that left me to do then was at that point the game was fully working. The game was working from beginning to end. Um, I think, in fact, no, the only thing that didn't work was the completion code. So I went through the completion code. I can't even remember what I did on the completion code, but yeah, there was a lot of sprite shuffling around. I think there was some timing issues as well. Um, I think I had to mess around with some offsets and stuff, but um, the completion's not a huge problem though. Again, it's similar kind of stuff to before. The only final issue really was the music. So what I did was I made sure I saved some space at 3000, um, which you can probably see. Did I do it down here? So originally I just had a fill in here, which would fill the memory up to this location here, just to leave a gap. And what Richmond Mike did was he took the music and basically enhanced it for dual SID. So now the music uses two SIDs. What it meant as well is we could use two SIDs for the music, and we could use the other two SIDs to do the sound effects. So unlike the original game where the sound effects would play would pause one channel in the music to play a sound effect. Now they can play at exactly the same time. There is still the ability to turn the music off, and turn the music off adds a couple of extra sound effects in that weren't in there before. Um, but all the sound effects can play while the music is on. So, and that was pretty much it. That was all there was to it. Really, the only thing I did before releasing it was instead of creating a single PRG that ran all the way up to one FFFF, I took the character set. So I took all this stuff here, created a file out of it, um, put it on the disk, and called it chars. And then basically it's part of my build. Actually, you'll see in here. Uh, where is it? Yeah, here. You see, I just write it to the disk at this point, and then I can load it through the code here. And that way you have something that will also load into the emulator, although the emulator struggles to um, load data from that location, or for some reason it struggles to load the character set in. But you can see it in Sprite in Xemu, and it does load, and you can play it. It's just you won't be able to understand any of what's going on because the graphics don't load. But the game is there. The game is there and is playing and has music running as well. So it could have used Z to store it faster. What you want about Z for? Oh yes, to store instead of pushing to the stack and stuff. Yeah, yeah, I could have done you right. But I wasn't thinking efficiently, if I'm honest. This was something I threw together very quickly. I mean, this was from beginning to end, in between everything else I did in terms of just raw kind of time, not raw, the actual elapsed time. I started this on like a Monday, and it was kind of done after the weekend. I think I finished it on the Sunday after the Saturday stream. So I was just showing off 10 a.m. No points for that. But we'll try and give you some opportunities to get some points soon. So that's about it, really. I think what I would have preferred to have done for this was to maybe do something like this on stream at some point, and maybe we will. Maybe we'll take an existing game and do it. For instance, I said this a while ago on stream, a couple of streams ago. I was messing around with my disassembler, and I realized I had the Iridium source code, disassembled source code, but Iridium source code nonetheless. That compiles in Kick Assembler, doesn't need any external files or anything. And I was thinking it would be an interesting task to just get that to run on the Mega65. However, obviously, I don't really want to do a game unless I have the rights to do it, and I don't think it would be fair for me to convert Uridium, but I would like to do one on stream so I can show you how easy it is to do. So maybe we'll pick a game at some point. Maybe I'll do Doc. Maybe I'll take the original Doc Cosmos and convert it. It would only take. I could probably do it in one stream, to be honest. I just need graphics. Um, Elite on the Mega 65. Elite would be a bit different because with Elite, the C64 is not very good at drawing bitmap stuff, right? So the vector stuff is highly optimized and highly targeted at the very specific kind of bitmap layout for the C64. If you were to do that properly for the Mega 65, I think you would treat it completely differently. But I think you would use a full color mode character grid lined up kind of like the Mega 65 Mega Maze, sorry, not Mega 65. Mega Maze kind of layout with vertical strips of characters, and then you would use that and probably DMA to do fills and stuff on them. I think you do a lot more than just port it. I don't think it would. I don't think it would benefit very much just being ported directly to basically. Other than the speed, obviously the speed would be a lot better. But then you can use an Ultimate 64 to do that. You can. I think you can actually speed up Elite. I can't remember. Pretty sure you can though. I think there is a version of Elite. I think it's like Elite Plus or something that allows you to speed it up. Right, I just need to lower my chair a little bit because it's a bit high. That's why I've been showing so much of me on the screen up there. So when I've been playing the piano, I need to be a little bit higher up. So right, let's get some cider. I've got no wine tonight. I'm just drinking cider. I felt so ill last week after drinking all the wine. I'm taking it a bit easy this week. So I'll tell you what I'll do. I'm going to play through a couple of levels just to relax a little bit. As I say, this is very much kind of just going to wing it. So we're going to play through a couple of levels of this. Let me get the right screen on. Let me restart. Okay, so we'll play through a couple of levels. Probably go to I'll play. I'll play for as long as until I get bored. I do get bored of this game quite easy because I did play it to death. So um, I'll do my best, but just to kind of chill out for a little bit, really, and then we'll work out what to do next. So we'll probably might take a look at Perseus next, or actually, I tell you what, if anybody's got any questions regarding the Mega 65, that's I think what we'll do next. I think once I get bored of this, I'll take some questions on Mega 65 and do my best to answer as much of it as I can. So play until you hit one of my levels. Yeah, that's probably what it'll be. Some of it I remember how to do. So bear in mind that I played most of these levels multiple times through testing. Um, but unfortunately, they're not the easiest thing to always remember. So yes, please. Are you saying yes, please to Elite on the Mega 65? Yeah, I gotta remember. Oh, that's right. Yeah, you pull these in. Yeah, filled vectors. It would work really well, but I don't think it's as straightforward as just porting the existing version. I'm sure you can use the quite a chunk of the code, but the rendering code would have to be completely rewritten, I think. Um, to the point where actually you might be better taking actually no, you could probably still use yeah, you could do it, I think. It's just it just take a little bit of thinking to get it right. Because you would have to change the rendering code. And if you were going to change the rendering code, you'd need to start thinking about oh, actually, it has hidden surface removal, doesn't it, in Elite? Because you see wireframe with hidden surfaces, right? So actually, it might work all right. I'm just trying to think about how the fill would work because you kind of want the fills to be reacting to light source as well. So you'd want I mean the actual algorithm for for shading something based on a light angle is quite simple and would definitely be easy to implement. But you still have to add some additional code around it as well. There would be more than just porting the code, I think. Or you could just do random color fills on something, but then it would just look weird. So struggle. Oh, I blocked the air hole. Elite the new kind source available. Oh, okay. Anyway, welcome, Deft. How's it going? Hope everything's well there in Megaland. I remember how to do this. No, I don't because I screwed it up already. Damn it. Yeah, screwed it up. All right, I remember though now. Yeah, I'm good. I'm good, thank you. I'm kind of enjoying a little bit of freedom at the moment because the Game Boy game is pretty much finished now. I've not had any, so it's been in testing for 2 weeks now, 3 weeks, 2 weeks. It's gone through several versions. We're on a release candidate now, and we haven't had any bug reports on it, other than that it's too fucking hard, too hard. Which it is. It is really difficult. But I'm kind of pleased that that's at an end now. So that's freed me up to look at Mega Drive stuff, which I'm really liking the look of. I kind of wish I'd looked at Mega 65, looked at Mega Drive a bit earlier, 68,000 a bit earlier, because 68,000 looks like a really fun language to use. Um, it's going to take a bit of getting used to. I'm not entirely used to. I know there's some stuff in there that's going to catch me out quite a lot. But generally, I like what I see from it so far. So I'm kind of looking forward to working with it. Um, BGN Elite shit numbers. Do you know what? As well, the thing is the big endian, little endian thing. So with with uh with little endian, it kind of makes sense on the 6502 because you need numbers in that order in order to add them together correctly, right? Because you can only ever do 8-bit additions, and you need to use a carry flag to kind of to do things. So the fact that things are in little endian order is kind of really a convenience for that kind of functionality. Whereas on the 68K, you don't need to add things together because you can do 16-bit or 32-bit addition. I assume you can do 32-bit addition. I haven't looked into it fully, but um, 12 shifts. 1, 2, 3, 4. Really? Is it that simple? One. Yeah, it is, isn't it? So the big endian kind of makes sense on the Amiga. So um, my brain still works in 68K assembly. Good. Um, yeah, it seems kind of, there's a few things I think are a little bit odd that I think are going to catch me out. Some of it sounds like the assemblers deal with. So, like for instance, the difference between add and add I is just that, for some reason you can move things between memory addresses. You can move memory address contents of a memory address to a register, so on. Move immediate to a thing, and you don't need to put an I on the end. But with add and subtract, for some reason you do. But apparently most assemblers will deal with that anyway, because you kind of use the hash to signify that this number is immediate, so it can infer that it's add I and sub I, which is fine. um, I just find it a little bit weird that there is a separate instruction for that, even separate mnemonic for that. And the other thing is, when you move words or long words, you have to do it on even numbered addresses, which I think is kind of it's going to be a bit weird. Oh, really? What's move Q? I don't know what move Q is. I've not seen that one. Oh, move quick. I see. See, I've not even. I've literally spent 10 minutes skimming over a tutorial. I didn't even read it. I just kind of looked at some instructions and stopped at bits that I just wanted to understand. I really like the indexing. I think the indexing is really good in the post post increment and pre decrement as well. I think that's really good. Although I find it a bit odd that you can't do both. You know, you can't do post decrement and pre increment, but you know, whatever. It's fine. But I do like the format of those commands. I think that's really nice. Oh shit! I'm going to do this one. Okay, right. So that goes there. Oh, I've still got it. I still remember how this works. Blue. Okay, so that's obviously there. Ah, man, is it too easy? We obviously haven't hit an Eldritch level yet. Oh god, this actually looks. Ooh, okay. That's my own fault for saying that, isn't it? Okay, okay. Think about this. Okay, so I need power to the lasers. 9 shifts. Okay, so well, this one points to the blue. I just need to get a battery on it. So let's see. That would be 1, 2. But then, how do I get the green into this? All right, now it's getting complicated. Let me just open this window in a. Down here, it just makes it a bit easier for me to look at. Uh, hmm. I feel like. Oh wait. No, I know. How do I reset this space? Okay. If I do that and then that, and then that. Oh, it's too many, isn't it? Damn it. Can relax for 13 now. I'm stuck already, so. Oh, damn it. All right. Think about this. All right, let's think about the red, because the red is a tricky one. Ah, okay. So one thing I can see is that the red, if I just do that, will hit. Okay. So really, I just need to get that green up somehow. Oh wait, that green. Okay, okay. I mean, that wasn't the way to do it, I'm sure, but I got through it. Oh, this is just a slow one, isn't it? Thank you very much for the follow. I can't see your name, Enga. Let me just move this window out of the way. Spudgunus Maximus. I like the name. Welcome to the stream. Hope you're doing well. Just taking it easy, doing a little bit of gameplay. Luma Mega65, and then I will take a look at Perseus, and we'll see what we can do. I think we had some basic collision in, so we can start kind of doing a bit more on that, I think. I just want to take it nice and easy tonight. I don't want to rush into anything. I don't want to stress myself out over anything. Just want to take it nice and easy until I can figure out exactly what we're going to do. I do actually need to speak to someone. There's potentially another Mega65 game that I could be doing, which is a port of an existing game, which would actually make for a very interesting Saturday stream. So I need to find out where that is. I think Def knows what I'm on about. Okay. Oh, it's this one. All right. Is it Tomb Raider? No. Oh shit, that's fucked it up. Yeah, snacked it. Damn it. All right. Good, because you're working on that. Oh, Moscow. Good guess. Was that a guess? Or was that redeemed? I can't tell. My chat got off for some reason. Guess but already found. Okay, yeah, good point. Okay, so there has to be a way of getting these out. And getting this out. Two. Wait, what? How? Oh, wait. God damn it. Okay, that's a quick way to get that one out. Oh, you son of a... Yes. I gotta say, it's a lot of fun working these out. Some of them are easier than others, though, obviously. Uh, this one stumps everybody until you realize something. I'm just trying to remember what it is I need to shift here. There we go. And it chose a great color for the gray part. Oh, for the mirrors and yeah. So one thing there's two things I've been trying to learn, right? quite a lot, because as I'm moving slowly towards Mega 65 and now Mega Drive as well, I've been trying to learn pixel art. So I've been doing a lot of pixel art tutorials, and that's taught me how to do things like this battery. I'm very pleased with. I think that looks really nice. And yeah, the kind of gradients on the bricks and stuff. I'm learning how to do that kind of um staggered kind of gradient. And because one of the things I would have done previously is I probably would have done those color splits, those yellow to brown splits, but I probably would have done them perfectly straight. And I've learned that actually if you just add a little bit of a curve into the kind of into the steps of the gradient, it looks more natural than if you were to just do it solid. It looks more well, as you can see, it looks better on the eyes. So yeah, learning that. And the other thing as well is learning music theory and piano as well. So I'm trying to get my head around composing music properly. So I've known how to write music, just not I'm not very good at the kind of music theory behind it. So learning that, as well as learning to play the piano properly. So learning how to not just play like one hand, play Mary Had a Little Lamb or whatever, but being able to actually do two hands and get used to playing bass on one hand and playing the melody on the other hand. And I'm getting there. I'm getting there. I can almost play Dire Docks beginning to end now from Super Mario, which is kind of good. It's always been a goal of mine to be able to play that one day, and I can almost play it now. So, and no, I will never play that on stream until I can play it perfectly without error. Because the moment I try and show, like I've tried to show my girlfriend, and the moment I try and do that, I start making more mistakes again. So, performance pressure is real. But yeah, I think it looks really nice. This on Mega 65, I think it looks good. I was quite pleased with the gems in the middle of the. Mary Has a Little Lamp stack is long. Ah, lamp. Or MAMP as I use. I think it's called MAMP, the Mac one. Would make sense, right? The acronym would work properly. Yeah, quite pleased with the gems. So I learned how to do gems from a little tutorial. I was going to redraw it for each angle so that the light source was the same depending on where they went, but I just couldn't be bothered. I got a bit lazy with it, so I just went down this route. But I think they look good. I think they look like little gems in the middle of the laser, so I could make a columns game now. Okay, this one's easy as well. They're lickable. Okay. This is Foray. Was it Foray or was it It was Foray, wasn't it? That was doing all the ones and giving them names. Because this looks deceptively easy, but you just know it's not going to be. Well, obviously one of these needs to go over, right? So let's move that one over. No, no, it's not going to work. So I feel like I need to put one of these here like that, so that when I move this piece over, it falls into that slot. And then this one. Damn, this one's tricky. Okay, maybe if I just move one of these up first of all. and that gives me that. Then I can do that. Then that, yeah, there we go. BT James Bond, that would be good. I actually haven't added. I added one single background in. That's a good point, Andy. Have you put your background on yet? You haven't, have you? I just haven't seen it anyway. Keep missing it. So this is about getting that battery over, right? That's the only thing this can be. And we've got 12 shifts. All right, let's see how many it takes. 1, 2. Oh no, because okay. 1, 2, 3. Yeah, okay. That's just about working out what way round to do it. Oh, I remember this one. I remember this one because this can be solved in a way that doesn't produce the desired pattern. But I'm going to try and solve it. Knowing what the pattern's supposed to be, I'm going to try and solve it with that pattern. But can it be done in 5, though? That's the thing. Okay, so let's see. If I want to get that to fire into here without moving, I'm going to try and do it without moving any of the lasers or the mirrors. I just want to move the batteries, really. So that would need to be here, here, or here. I don't see how that's going to happen, though. Well, that's a blue. Then that doesn't give us this. Oh, 1, 2 moves. Okay. Hmm. I feel like this can't be done the way it should be done with 5. Yeah, I have a feeling that's the case because we went through and changed all these levels to make them, to do them in the shortest amount of moves. It may be that we did a method that actually changed that mechanic slightly. So I think we probably did something like this. But then I don't know what. No. Oh, he's fine. Oh, wait. Yeah, that's done. I did that. There we go. It's kind of right. I don't think it's the exact solution, but it does work in 5. And all I had to do was move the batteries. Okay, cool. I think I'm gonna move on to something else. Well, let's just have a look what the next one is. All right, let's do one more, and then I'll move on to something else. So I think we'll do this, and then we'll take a look at Perseus and see where we can go from there on that. Um, uh, hmm. This is deceptively difficult. This looks like it should be easy, but it actually looks quite difficult. Uh, okay, so that would give me enough to get that into there, which just leaves me with this one. Boom, one left over. Yeah. You can see actually on here one of the sprites. So you see the little spark sprite as it hits the edge. That's just the original spark sprite from the C64, which is why it's got that kind of multicolor sprite vibe going on there. There's a few little bits like that. So the success message at the end is unchanged, but that had a high res overlay. In fact, it is slightly changed. I think I edited the colors slightly on it, just to make it look a slight bit different. But I didn't see the point in changing the spark. It's not. It would have been more effort to change it than it was probably worth. So. That face. Such a face. Such a cute face. I hope that's all right, Andy. I had to kind of crop it to make it fit properly. So, um, for those who don't know, Andy is a dog. Um, he's just a very intelligent dog that can use a computer. I mean, he's not too intelligent because he does like the Atari ST. So there's obviously some mental deficiencies there, but it's all right. We forgive him because he's got such a cute little face. All right, let's take a look at something else then. Ooh, look at that. Inception. And his magic treats, yeah. Oh no, deft, dearie me. Oh no. There you go, Andy. You found the other ST fan. Also, she's a lady dog. It has a 68K, yeah. Yeah, I guess there is a saving grace for it. Um not much else. So. Neo Geo was something I was considering, definitely considering. When I was looking at the 68K machines, Neo Geo was definitely up there. But apparently there are some kind of funky, well, not limitations, but kind of architectural decisions that they did on the Neo Geo that makes it less than fun to code for. Plus, I think the Neo Geo market is kind of a lot smaller than probably both the Amiga and the Mega Drive market in terms of kind of people who would end up, you know, purchasing that game or having real hardware to try and. Plus, yeah, getting a Neo Geo is not a cheap task either. So, um, I went for Mega Drive because it looks like the most fun out of all the 68K machines. in terms of kind of capabilities. It's got very classic kind of tile maps and things like that. So it's still going to feel a bit like the stuff I'm used to, but with I think it was 80 sprites on the screen at once, 32 by 32. I think is the size, which is plenty for what I want. Right. Okay. So, has anybody got any questions before we start looking at Perseus? That they may be being confused about Mega65 stuff for the competition. So there is 1 week left on the competition. So we will do. Oh yeah, please do. We'll take a look at that. Yeah. What is that actually? Strider. Oh, Strider. My God. Processing video. Okay, it's still processing. So when it's ready, I'll show it. Yeah, so we've got 1 week left on the competition. It's not really a competition; it's a challenge. This, so anybody who submits anything that's remotely a game, um, will be eligible for the prize draw. Oh, there we go. Oh yeah, okay. To be fair, that's quite good. Let's just wait for the race to go so we can do that. Let's answer some of these questions then. What's the best way to deal with character attributes when using full color character mode? You mean yeah, that green background there. It's good job the green screen doesn't pick that up as well. Okay, let's press play on this. All right, let's just watch this and then I'll try and answer that question. I'll have a think about it. Give me a few minutes to think about it. Is it loading? Oh, there we go. I do like the colors in the metallic text at the top. That's really nice. So if the Atari ST can do stuff like this, why was it always inferior at scrolling in games? Why couldn't it do like good smooth scrolling in games? What limited it? Was it because it wasn't speed, surely, because it looks like it's fast enough to do some pretty cool stuff. Screen layout, okay. Okay. Had to work in words, not longs. Okay. That looks really cool though, Deft. I like it. So doubled the work. Ah, right, okay. Okay. So Def, were you an Atari or Amiga, or did you do both? Did you scroll inspecting her? Ah, okay. Okay, interesting. Oh, you were both. Okay. And which one did you prefer out of the two? Let's get on my next side. Find my empty cans up down there. Amiga was better, but ST more of a challenge. Okay. Oh, and it's interlaced as well. So okay, yeah, that would wind me up. See, I honestly thought when I started doing Mega65 that I'd probably get bored of it quickly because it's what's that not loading? There we go. Because it didn't feel like much of a challenge. Or I thought it wasn't going to be very challenging, but actually, what I really like about it, about the Mega65, is that it's very much in the Commodore style. So even though you do have tons more power and you can do loads more things with it, and yes, the things that you would we would stress out about, like, scrolling full color on a Commodore 64, are no longer an issue. You can do these very, very quickly. Copying blocks of memory around, you've got a DMA to do it. So all of the things that you used to worry about on the Commodore are no longer a worry, right? And that's what I thought was going to make me get bored of it quickly. But what I found very, very early on, like literally within the first week or two, as I was kind of exploring around, that was that yes, those things are easier to do now, and you don't have to worry about them. But there's a whole other world of things in there that you have to kind of work around, or you have to understand. The color, the palettes being a prime example of it as well. People have been struggling to understand the palettes, and it took a while for me to get it as well. Um and it's because of that kind of weird, kind of slightly unusual way of doing things that makes it still feel like a Commodore. That, and the fact that all the Vic registers are still in the same place. So, but to go back to Skunk Monkey's question, what's the best way to deal with character attributes when using full color mode? Can't use the upper nibble. What do you mean you can't use the upper nibble? Let me just check what the attributes are. So in full color character mode, you get super extended character attributes, which is in the manual somewhere. I'm just trying to find it now. I definitely have it. It's one of the most used pages in my manual. There you go. And so that gives you screen RAM and color RAM. So it gives you 4 bytes, right? You use 4 bytes to display anything on the screen in 16-bit character index mode. So in 16-bit character index mode, every screen location takes 2 bytes. And likewise, the color RAM is exactly the same. Color RAM takes 2 bytes. Now, in full color character mode, the color RAM doesn't really change the color, because you're defining the color by using full color character mode. Every pixel points to a color in the palette. So there isn't really a need to use color RAM for that. However, you still need to use color RAM to do other things. So in the manual, there is a table. And this is quite an old version of the manual now, but there is a table. um, in my chipset manual, it's at 216, page 216, but you'll probably find it's a few pages uh, ahead of that or before that in the latest one. But this lists what the extra attributes are for that. So the way I tend to do it with full color character mode, which to be fair, I don't use a lot now, although the nibble mode is essentially kind of an extension of that. Um, but what I will do is I will, when I clear my screen, um, I'll have a screen clear routine with DMA or otherwise that clears the screen RAM with a 16-bit value. So it'll clear all the screen RAM to say 0400. So each screen RAM is pointing to very specific area of memory. 0400 points to 10000 in memory. So the first kind of location outside of the 64K. So I'll clear it to that. So that's my space kind of character sorted out. But then color RAM, I'll clear to all zeros. I'll absolutely clear it to nothing but zeros. Because color RAM has a few effects. So um, there are 2 bytes in color RAM, and they will cause you to flip characters, um, turn on 16 pixel wide characters on a per character basis. This is as well. Do the raster rewrite buffer go to, trim pixels from the top or bottom and from the right side of the character. You can set the lower 4 bits of color, which is only really used in the 16 pixel wide characters. You can turn on hardware blinking, reverse, bold, and underlining as well. So it's best to clear those with zeros completely. I can use Coloram to store solid char depth for collisions. No. I see what you mean by character attributes. No, I wouldn't use Coloram for those, because Coloram in full color character mode has these additional attributes. So you can think of, from what I was doing on the Game Boy. So when you've got Game Boy, you have your screen RAM, and then you have attribute RAM. An attribute RAM is what you're used to calling color RAM on the C64. It's basically a copy of the screen's kind of layout that controls the attributes for each individual character. Now on the C64, the only attribute we can control is the color. Um, on the Game Boy, you can control the flipping of a character, whether it appears in front or behind sprites. um, and which palettes to use and things like that. In full color character mode on the Mega 65, it's more like the Game Boy than it is like the C64, in that you can control whether a character is drawn flipped, horizontally or vertically. But it also controls some other things as well. So you can set a character to be thinner or shorter or wider by the use of various kind of trim and 16 pixel wide things. You can also tell the raster rewrite buff to draw somewhere else on the screen. But the point is all of those bits in the color RAM are used for something. So you can't just use color RAM to store additional information. So what you're better off doing there is you can either have a per character table, same as we would do on the C64. So just keep another table somewhere with your attributes on a per character basis, and just use an offset. So say you've got your characters are all stored at this location in memory. That's a character index of 0400. And that means your first 256 characters will run to that location. So that's character numbers 0400 to 04FF. So what you could do is, if you want to have a character index, an attribute table for all the characters up to this point, say you've got 64 kilobytes of characters, you could store another character table here that goes from 20,000 to what would it be 23FF, like that, and just use whatever your character number is, which is here, and just change that value. So you're grabbing an offset into this. So these are your character numbers, and these would be your offsets into the character attribute list. So that would be one way to do it. Another way to do it would be to do it on a per screen basis, and as you build the screen, um, so you need to use additional memory space. Yeah, exactly. Another way to do it would be, as you build the screen, is have a shadow, what I call a shadow attribute RAM, which means, so say you've got a screen that runs from like the typical 0800 to let's just say it runs like that, which is an 80 column screen. It's a bit less than that, but let's say it's stored there, and your characters are still stored in this location. You can still have a character lookup, or what you could do instead is you could get rid of the lookup table, and in your map data, you actually store two maps for every screen. So you store your visual, like your visual character map, and then you have another map, say um, here, and that's just your attributes. So whenever you look something up on screen, you can then look at the same thing up in this shadow screen and use that as an attribute. That's something I kind of do on the Game Boy as well. So even though I do have a collision table that I look up, I actually put that into a shadow attribute RAM. And the reason I do that is because when you switch between timelines, it makes more sense to change both of those at the same time, rather than kind of look up a separate table and recalculate things based on that. So it makes it a lot quicker for me to look things up every frame in a new screen, rather than have to kind of work out which timeline we're in and stuff. I can just reference this straight away. So it just depends how you do it. But yeah, you can't use color RAM to store things um, without kind of affecting the stuff on the screen, unfortunately. Uh, Look at those eyes. How can you change that? It is such a cute doggo picture, that it really is. The full picture is even better as well, because it's just like a proper attention thing. But unfortunately, I couldn't fit the whole thing in. So anyway, yeah, that's how I'd approach the character attributes. You do need to reserve a bit of extra memory, but bear in mind as well, you've got oh god, it's really something sore on my nose for some reason. Bear in mind, you do have 384 kilobytes. That's always available to every Mega 65, so you have plenty of room to do that. Just make sure you bank out you turn off the read only for the C65 area, so you can write to it as well. Okay, cool. Let's take a look at where we are with Perseus. I can't even remember myself. It's been a while now. I wanted to get the Game Boy thing finished, so I've been kind of putting off doing some more Mega65, but now we need to kind of crack on with this and get into it properly. Oh, yep, no problem, Microman. I just got your message from. Oh, it was 10 minutes ago. I thought it was longer than that. Yeah, I should let that. I can't add it now. It'll have to be after the stream, but yeah. In fact, can I save that from here? Yeah, okay. Just gonna do it now because otherwise I'll forget. So there we go. Cool. Done. Consider it done. FCM backgrounds and FCM sprites can take up a lot of room. 192 bytes for each sprite data. Yes, that is true. This is why the 4 bits per pixel, 16 pixel wide characters is a much better approach, and that's what I'm using in Perseus. Because what that does is it halves the amount of room that these things take up. So I don't even use hardware sprites at all, because hardware sprites have a few limitations. Firstly, there's only 8 of them, so you'd still need to do a multiplexer. And while making a multiplexer isn't too bad, you're still at the you've got 40 megahertz. It's super easy to do a multiplexer when you've got 40 megahertz. And you can easily get 64 sprites on a screen at one time without any issues. The only problem is you're still at the mercy of the hardware sprites, which means you can only have 8 on a row before they start flickering. Now you can on the Mega65 set rasters on the X position as well as the Y position. But the problem with that is you would then have to do that on every single line in order to get more than 8 sprites on a row. So with raster rewrite buffer sprites, which we use in Perseus, the limitation is down to us. It's down to whatever we set. So the way I do it in Perseus is I have. Let me show you the config. So let's say I've been documenting the hell out of this. So this is how you set the layers up in my game. Now all these layers are done with 16 pixel wide characters, which are 16 color kind of characters instead of full color characters. But 16 colors per 16 by 8 pixel block is plenty. And it's certainly enough to do anything kind of the Amiga kind of level detail. And also bear in mind that normally on an Amiga game, what you would have is 16 colors, and that's it. You would have 16 colors. You could pick those 16 colors from whatever you want, but you would generally just have 16 colors for your backgrounds, and then another 16 colors for your sprites. Yeah, but it's 16 for background, 16 for sprites, right? Oh, for 2 BDs. Okay. Oh, wait, no, BD. BD. Okay, so you could have 32. But the point is you wouldn't have 256 on the screen. You would have a limit to your palette, right? With this system, you would have you can have 512 colors. You're just limited to 16 in any 16 by 8 block, but you can layer those blocks however you want. So I can create a character with 16 colors, and then another 16 colors in another character, and then another 16 colors in another character. But then I can use the raster rewrite buffer to overlay them as well. So you can change them every raster. Like, yeah, well, I mean, if you take the kind of raster splits out of the equation, yeah. Which I realize with Amiga you do with the copper, right? Which makes it a bit friendlier to do, right? Yeah, exactly. So you're not having to set kind of raster splits up, but if you take those out of it, because you could essentially create a copper list kind of thing for the Mega65, it wouldn't be a difficult task to create something that uses a timer, because you don't have bad lines. On the Mega65, it'd be a very trivial task to create something that emulates the copper, by just using a timer, right? So you could set an NMI timer up, which times exactly one line, and then processes a list of data. You could even use DMA to DMA it into the IO registers. Um, so you could do some tricks to emulate copper, but I don't think that's going to be something that people do very often, unless they really just want to port a game directly. But yeah, so the reason I set it up like this is so that I can um, add layers in on as I please, right? And one of the layers, most of the layers are just normal layers like this. You point it to some data which defines kind of the size of the data that fits into this layer. Um, Although it doesn't actually load them, and it just uses this to count the size of it. Um, they're all basically the same, except for one layer. This layer which I call the sprite layer. And what the sprite layer does is instead of loading in a set map or anything, it just reserves some bytes. So in this case, we reserve 112 bytes. This number you can vary. It depends on how much other stuff you've got going on. You'll reach a point where when this gets too high, the screen will start rendering oddly, and you'll know to lower this number. So this is kind of like your performance limit. But what this number does is this reserves 112 bytes just for raster rewrite buffer sprites. Now, each sprite takes 2 bytes to display, and 2 bytes to do a go to, so it knows where to jump to. So that's 4 bytes for each sprite. So if you take this number and divide it by 4, you get 28. 28, is that right? Yes, 28. And that gives you the number of sprites you can have on a line. So you compare 28 to 8, which you get on the hardware, and you can see we're almost 4 times as many sprites on a line before we start seeing flickering and things disappearing. So this is why this number is here. It's just so we can kind of define how many sprites are on a line. And it's quite simple how the raster but I mean, I've gone through this before, and we'll probably do a full kind of stream on this once I've got this framework up and running. But essentially, what happens is when it gets to um, once per frame, what happens is this sprite layer is interweaved into the screen data, right? So once per frame, it will use DMA to basically clear all those sprites, so nothing is in them, so it's completely blanked out. And then the sprite update routine will take the list of sprites that we've got, which use normal uh, normal kind of sprite data things that we're used to seeing, x and y position, pointers, colors, attributes, and use them to work out where they should go. And the great thing about this system is it means you don't need to sort the sprites. You can just place them in one at a time and just drop them in exactly where they need to go. You're basically preparing the screen ahead of time, so then when it comes to drawing these rows, this data is already populated in each one of these. And the end result is we get sprites which are made of characters but look like sprites, look and behave just like sprites. And why is that not? Let's get on that one. Is it that one? Why is this not loading? What's going on? Have I got the wrong? Oh, because I've got that open. That's why. So we see down here as it loads. It's not as good as the M65. No, I mean the copper has its uses. Definitely has its uses. Oh, I've got the wrong disc in. Oh shit. Okay. Okay, that's fine. So the reason we're seeing junk on the screen there is because all my character data is on the disk. I don't upload this every time. It's all on the disk that's stored into. Oh, why am I disappearing in the corner? What's that about? Ooh, I need to fix that. Not like that. There we go. The green screen is a bit weird. I do need to get a good diffuse light for the green screen. I like having it though. It's kind of cool. It means I can have a mess behind it. Okay. So this is my disc, and I think, yeah, you can see Perseus here. So this, I'm not sure what this is actually. Let's take a quick look at what that is. It's probably Luma or something. Yeah, it is Luma. Okay. So by default, my Mega65 is set up to just read the first disk it finds, called disk.d81 by default. And so what I do is I put all my oh, that's, wait, have I just opened the wrong thing? It's called Luma as well. What the hell? Ah, that's it. It's that one. I'm going to get rid of that one. Don't need that one. Oops. Now, I do know that Mega65 connects and will transfer PRGs. And I also know that you asked for Willow. That's what you got. I had three options. I had three options for Willow, and I went with the one that would cause the most controversy. Hey, Warlock, welcome to the stream. I had the option of Andy's dog, Willow. I had the option of Willow from Buffy the Vampire Slayer, and I had the option of the movie Willow. So I went for the movie, just to troll you all. So be careful what you ask for, because that's stuck now. That's always going to be the Willow. Okay, let's try again with this. BG Sexy Willow. Oh, careful. I mean, I can only really interpret that as, I mean, it'd have to be Buffy Willow, wouldn't it? I guess. There we go. Okay, so I can't remember. Oh yeah, we did have. That's right. We did have some collision checking in. That was just keeping me against those things, but we don't have any proper backgrounds in yet, so that's why it looks a bit weird. Also, it's constantly running. Also, that's obviously off the bottom of the screen there, so you can see kind of junk down there. And also, there is no definition between what is space and what is background. What's passable and what's not. Anything with a pixel is deemed passable. So anything that's not space, basically. Lesbian witch Willow. What's reading this week's Willow? I was reading this week. Willow's magic stick was a cooler concept they found and made several fiberglass versions in case the original one broke. I didn't even realize that. Okay, so obviously one thing we definitely need to do here is we definitely need to have a character attribute list, right? Thing is, I don't want to do that until I have the proper backgrounds for this, because at the moment all I have is this temporary kind of background, and I mean it's enough for doing testing, but I don't really want to start adding attributes in for stuff that is not going to be important. So I'm going to wait for that one. Hopefully, I've not heard from Stoker for a while, but then again, I've not really had much reason to need anything yet. So, but that's going to change over the next couple of weeks. So, hopefully, I can start getting a bit more from Stoker and start building up this game. So, I think what I want to do is start thinking about possibly the controls. I mean, obviously, there is no proper gravity in this either. Controls would be good though, because then we can start to get a feel for how the game plays. So not going to bet races until Bobby's removed for good. BG Buffy. Yeah, these are good ones. I need to catch up with the. I need to catch up with the backgrounds. I think I've got like 2 streams worth that I need to go through and add. Okay, right. Any more questions before we crack on? Let's just get on with this, I guess. All right. So player control. Let's take a look at that because I think that's probably a good place to start. I've got a couple of animations. I don't think they're all in there yet. Let me just have a look at the make file, see what we've got. Okay, so we've got map test 3 and sprite test 3. So let me just have a look at what those files are. Uh, got the right folder there. Okay, there's map test 3. So this is just going to be our map with some layers in. Okay, we don't really need that one. That's going to change quite a lot. But what we do need is this one. Okay, so we literally just have 3 sprites in here at the sorry, 1 sprite. Not a lot else. Okay, that's fine. So let's have a go at adding more sprites into here because I do have some more animations in here. So let me open up one of the. Is it this one? Yes, that's run and turn and ledge climb as well. Okay. So these are the animations I have at the moment. So I wanted Perseus to be able to climb ledges, but I wanted it to be a fast animation, not something that's like flashback is quite a slow climb, so it would have taken a while to kind of to run at a wall and then jump and climb up. I want it to be very fluid, very quick. So what we've got is a very quick kind of animation. It's quite short. It's only actually that last frame's the same, so it's only actually 7 frames, or actually 6 if you count from there to there. So the start frame, which is basically the idle frame, to that. So and at that point, the sprite will move to elsewhere. Now, the only thing I do need to do is I need to adjust this so that this sprite is always. I might need to kind of mess around a little bit in it just to make sure that the sprite always fits within the kind of range that the dimensions that I need it to fit within. So I'm thinking this one might need trimming ever so slightly. That one looks probably fine. And so on, but that's the idea. So that's the ledge climb. We've also got run and turn. I thought I had a. Yeah, that's the turn. Oh, turn can also be used as the idle frame. Okay, good. Let's. Hey, Worlds of Rogue, welcome. Let's take a look at this animation and move this into making a game for Amiga. No, Mega65, as Andy says. So system quite definitely more powerful than an A500. I think it's slightly more powerful than an A1200. But similar in terms of kind of the look, just a bit more kind of a bit more color and a bit kind of faster and stuff. So I should have a Mega65 command actually, shouldn't I? So people can spam that and then go and find out about it. So in fact, let me quickly add that in because it wouldn't take too long to do. We do that here. Add command. Computer. Need to get the web address and I'll set the Discord up on it as well, I guess. Discord. Let's grab a Discord address for that. Invite people. Edit invite link. Never expire. No limit. Generate a link. I don't know why that's hidden, but it is. All right. Oh crap! Where's my? Where did that go? If I just lost that page because I did that, that's stupid. Yeah, I have. Oh my god, that's dumb. Okay. Check out the exciting new Commodore computer, the Mega65 at there we go. Hopefully that works now. So you just do a Mega65. There you go. Bit of advertising for them. Cool. Yeah, so Mega65 is a new computer based off the prototype, the Commodore 65, that was never officially released. There's a few prototypes made it into the wild. You can pick one up for the cheap price of about 50 grand if you've 50 grand, or probably about 20 grand if you're lucky. But I've seen them go for 50. They're very expensive. And their prototypes, I think they only ever made about 200 of them, maybe less. And the Mega65 is a modern version of that. So it's a fully compatible Commodore 65 with some additional stuff in. And that's why it's called the Mega65, because the Mega65 is the additional stuff. And it's a great computer. I absolutely love it. I've got the dev kit here. It's very, very cool. And I like making stuff for it. I'm also trying to get as many people as I can from the Amiga and Commodore communities, well, any coding communities actually, to also own these machines. So I run a monthly challenge where I set either a coding. Well, it's almost always a coding challenge of some kind. Sometimes it's solve a kind of problem. Sometimes it's just make a game, and the winner each month gets an FPGA board that's capable of running the core from the Mega65. So that's kind of my that's what I'm trying to give back to the community, to try and give the Mega65 the best start it can when it finally arrives. And I think so far we've done all right. I think we've given away 5, 6, something like that. I can't remember. I should code a demo at some point. Yeah, I should, shouldn't I? I wonder what I'd do. Oh, actually, that so one thing I really can't. I'm not up to date with my Mega65, so you'll see I'm stuck on ROM 911210. I can't use anything higher than that, because the problem is it's something changed in the ROM beyond this point that prevents me from using M65 to connect to it from. So when I do, when I do my build in here, and it runs through my make file and uploads to the machine, this doesn't work on later ROMs. So I'm stuck on this ROM until that gets fixed. And I'm not sure what's going on with it, because it seems to kind of be bouncing around between Tega and BitShifter. I think people are a bit confused over where it actually lies. So I'm kind of because I'm kind of excited to use the later ROMs. So I think it's been yeah, I think the last I saw there was a little bit of progress on it, but I think people are still a bit confused over exactly where it lies. I think Paul's right though. I think it is a vector thing. So Proton doesn't want to do it. I've been trying to talk Proton into doing some Mega65 stuff, and he's not interested. And I don't understand. I don't understand why at all. Yeah, I don't know why. I don't know why. It's a weird one, but I think it's the perfect machine for a Commodore demo programmer to be playing around with. I freaking love it. Get Ace to do Mario 65 Cement Factory. We could convert that in a night. Definitely converted in a night. So, oh my god, yeah, I really need to get proper controls into this. Yeah, the parallax. Yeah, it's the parallax works really well actually, and it is using 5 layers of parallax, I think, plus a sprite overlay as well. Convert Warlock's Toxic Frenzy. Yes, if you want me to do that, Warlock, I'm happy to do that. Because the more games we can get onto Mega 65, the better. If you're happy for me to do that, I'm happy to do it. It's an easy task. You could probably do it yourself actually with Xemu, but if you want me to do it, we can maybe we can do that on next week's stream and convert it. Um, um, I guess it would benefit from full color characters artwork as well. So maybe if we do well, I'm going to take Tuesday off, so I'm not going to do a stream this Tuesday. Yeah, I think that's not a bad idea actually. Yeah, if you're happy for me to do that. Actually, anybody watching who's got a game that they want me to port to the Mega 65, as long as you're happy for that game to go for free onto the Mega 65, because I don't want to spend time doing something that is not going to be free for people to use. The whole point of the conversion of Luma was to give the Mega 65 community a game which is considered a full game for free. So if anybody has got a game that they want me to convert, let me know and we'll do a stream about it. So next week I will do that, Warlock. I'll take your code and we'll get it. First of all, we'll get it building, and then we'll get it running. If you do have an idea for what you would like the characters to look like on a Mega 65, you can either kind of create the new character set yourself, or we can kind of work together on that or something. Because obviously there's no point in converting it if we don't upgrade the graphics somehow. So that would be the main thing that we'd look at doing, is upgrading the graphics. But we can use the same kind of pattern that I've done with Luma, and we could probably do it in one stream, I reckon. I mean, bear in mind I haven't used it. It's sprites plus koala. Oh, it's got bitmap in it. Okay. I haven't done any bitmap actually on. Okay, so the background is a bitmap. Okay, and then you're using sprites over the top. So the sprites thing can stay the same. All right, I'll have a chat with you at some point before the stream. We'll try and work it out. If we can figure out a way to do it, then we'll do it on the next stream. But I haven't done any bitmap stuff yet on the Mega 65, but we might be able to get away with not doing bitmap stuff and just using full color character mode. It might still work because all we need to do is create a screen of graphics, right? We can do that in full color character mode very easily. So yeah, all right, yeah, all right. We'll that we're on. That's what we'll try and do next week then. Okay, so back to this. What we're going to do today on this? Okay, I'm going to add some extra animations, and that's what I'm going to do. So I'm going to take I'm going to take this sprite here. So we've got 8 frames here, which is this running animation. And then we've got what looks to be 1, 2, 3, 4, 5, 6. That one probably doesn't need to be there, that last frame, because it's just that one mirrored, I think. Yeah, it is. Okay. So we only actually need 6 frames here. Sorry, 2, 3, 5 frames here. Okay, so let's create some space for these 5 frames in this. So let's expand the size of this canvas. Let's keep it 256 wide, and let's just double its height now. I'm also going to up the version number because I'm worried that in doing this that I'm going to break things. Um, so I haven't touched this for a while. So I just need to copy these in there. So it'd be good if it's snapped actually. Can I turn sprite grid snap to grid? There we go. So this is going to be our idle frame. Sorry, this one here is going to be our idle frame. May actually get Stoker to add a slight kind of slight movement into. Oh, why is that doing that? It's weird. Add a slight movement into it so that there's just a little bit of kind of small move, just a bit of rocking motion, just so it doesn't look completely static when he's idle. But for now, I mean, it's not important for now. These are the kind of polishy things that we'll do at a later date. Why is it doing that? That's really weird. Copy into here, paste. There we go. But this is just a turn frame. So one thing we didn't want to do was just have the player just immediately, yeah, like a drunken swear, yeah. I didn't want to have the player just immediately mirror and move the other direction. We wanted there to be some motion between that, because one of the things about these games is when you see the player running and shooting with a gun, say they're running, as you can see there to the right, the gun's in his right hand. Okay, so as he's running, the gun's in his right hand, but then when you change directions, the gun is suddenly in his left hand. So that's kind of a little bit jarring. If you really focus on it. It's not something I've ever really paid attention to, but now I've thought about it once Stoker says to me, it seems a bit jarring. So what Stoker's done with these animations is created an animation where he swaps, as he's turning, he swaps the gun into another hand, and that should kind of smooth out this animation a little bit and make it make the turn feel a bit more fluid rather than a jarring kind of. Why is it doing that? It's so weird. First time I paste, it just overwrites everything. And then go back, copy. This might be a bug. And then paste and it's normal. Yeah, I think it's a bug. That's not normal. I've been learning how to do rotoscoping as well. So I'm sure everybody knows what rotoscoping is. It's a method of animation that was used in Prince of Persia and Flashback and stuff like that, to create kind of fluid character animations. And I'm gonna use that for Doc. So for Doc 2 on the Mega Drive, I'm gonna actually rotoscope myself, performing various actions. Obviously I'll trim the belly down. I mean, Doc is a bit chunky, but it's not this chunky. But hopefully that will give me a decent base to start with the animation, because the shading thing I've got the hang of now. I think I can shade in pixel art quite well. What I can't do is is character animations. So Monty Mole was also chunky. 5, is that right? 5, 1, 2, 3, 4, 5. And then, yeah, it is 5 frames. All right, cool. Okay, so this gives us 5 frames that we can add. So first of all, what I want to see now is if I save this out, I change my sprite to work on that. and then give this a build, is it still going to show the same sprite there? Hopefully it does. Hopefully it doesn't change anything. We all have middle-aged COVID, but oh god, I'm up. Yeah, I'm probably up about 18 as well, actually, Andy. Probably about that. I've gone up so much in this time because I don't go anywhere. I don't exercise. Um, I mean, I didn't like go out of my way to exercise before, but what I did do was walk to a tube station, get up and walk around the office and stuff. And I didn't do any of that for the past year and a month. I haven't done any of that. My getting up and walking around is going to the kitchen, usually to get more food. So COVID. So yeah, I put a lot on. I probably put around about 20 kilos or something. I put an awful lot on. 12 steps to the toilet, 25 to the kitchen. Yeah. Yeah, that's the thing. The only time I'm really getting up now is to go and get snacks or excrete the snacks. That's about it. Lost like 15 kilograms and I started running during the pandemic. Oh, very cool. And I'm jealous. I wish I could do that. I even bought an exercise bike. I've got a nice fancy exercise bike, and I just can't bring myself to use it. I just not interested. I got it. I've used it maybe 2 or 3 times. She uses it more than I use it. Shame, really. I did want to do so. I mean, everybody's seen the Peloton adverts, right? I was thinking about this the other day, right? So most, hey, Anton, cheers, Anton. Welcome to the stream. I don't know if you've just joined us, but welcome. Thank you for the bits. Very much appreciated. Um, yeah. So I I was looking at the Peloton stuff, and Peloton, for those who don't know, it's an exercise bike that comes with an LCD screen on it, and the LCD screen has got like learning exercises, and you can join spinning classes and things like that. And it's a really good idea, and it's much more motivating to do these things if you've got some kind of challenge about it. If you're just kind of staring at a wall while you use an exercise bike, it's awful. But what you can do on it is you can do kind of races against other people and stuff like so you can do all sorts of kind of crazy stuff. But the problem with the Peloton bikes is they're very expensive and they're a little bit overkill. Like so I've got my exercise bike set up in front of a TV and I was just kind of because I had the TV on the couple of times I did use it. I had the TV on, I was just watching I can't remember what it was. I was watching something on Netflix anyway. I was thinking it would be a really simple task to get a Raspberry Pi and program a nice interface for it that just takes input from. So most exercise bikes, if you don't know, they have like a little lead that comes out from the wheel, and every time it flicks past, it sends a switch signal, basically just a tick to say the wheel's gone round once. Um, and they have a few other sensors as well, like on the handlebars for um, checking kind of heart rates and stuff like that. So I was thinking you could take that, you could attach it to a Raspberry Pi, and you could make all sorts of kind of crazy games and stuff, and just plug it into your TV. And I was thinking that would be a much cheaper solution to sell like a little box that you just stick to your bike, plug your bike into it, plug it into the TV, and you can have kind of crazy things like the races we've got, the gambling races we've got. Imagine if you could control the characters with your bike, and you could join a race with 8 other people and so there's lots of things I was thinking you could do that would make it way more interesting. For me, it's about gamifying it. If you gamify something, I will do it no matter how. It's the VR kind of Beat Saber effect. Beat Saber is great exercise. Um, but I don't have VR, so I can't do it. But yeah, with Beat Saber is great exercise, and the reason why so many people who would not normally exercise do it is because it doesn't feel like exercise. Physically, it feels like exercise, but mentally, they're just playing a game. And not only are they playing a game, they're playing a game which is to music and with lightsabers, so it feels really cool. You don't feel like you're doing exercise properly. So yeah, I was thinking, gamifying these things, it'd be kind of cool. So yeah, deathmatch cycling, yeah, be good. Anyway, um, I might when I move. So I'm going to be moving probably in November, and when I do, I want a much bigger place. I want a bigger place that I can set this kind of the streams kind of area up to be much kind of better and neater and have more room, but also probably have some kind of gaming area so I can get VR again. So it's been a while since I had VR. So okay, so Perseus is running using that animation. So what we can do is we can change some of the code now to actually point to a different animation and see if we can get a different animation running here. So first thing we need to do is just open up a couple of windows. So let's create a layout, two columns like that, because obviously the one on this side you can't see very well. So I'm going to use working on this side. Um, and so on this side, what I want to have is my animations. So at the moment, the animations are kind of hard coded in here. But this animation config should probably be moved now into config. So we've got layer config here. So we're probably going to create another one in here. I'm going to call it animation config. An animation config is basically uh, .s. Let's do that. Yep. Animation config is basically this chunk here. And all we need to do is make sure that that gets imported as part of our framework. So now that doesn't have to be, it doesn't have to be in this file. We can import it into this file. Same way we import the layer config. So if we go and have a look at the layers in here, you'll see that somewhere in here we import that layer config. I can't remember where it is, but yeah, there we go. Import the layer config. It's going to be the same in here. And basically, I want to do this with all our kind of configurable kind of pieces like this. I want to import these things like this at the start of our kind of. See, why is it using capitals there? It probably shouldn't. It's not using capitals in there. Let's go and change that in here actually, because that should all be lowercase. Uh, and that means like you can come in, you can define the layers like we do here with the layer config, but you can also define the animations as well. So at the moment we're using this animation. I probably need to put some details in here about what this is. So the way this currently works is all our animations are the same height, which is part of the. Is it this one? Nope. There's a value somewhere which defines the height of our. Here we go. Rewrite buffer sprite height, which I do need to abstract out, which I will do at some point. But for now, it kind of lives here. Actually, I guess that could that go in the animation config? Probably could go in there. All right, let's try that out. Actually, let's see if this builds. So this is the default height. At the moment, they're fixed height, which means all our sprites are going to be that high. And what that means is every character that makes up this sprite is 8 pixels high. So in order to draw a sprite that's high, it needs to use 6 characters. And we can see that in our sprite list here. So if we look at this sprite here, you can see each one of these rectangles is a character. We're in nibble mode, 16 pixel wide character mode, which is 16 color per character, or nibble color mode as it keeps being called. So each one of these is a character. You can see there are 6 characters that make up the height of this sprite, so for a total of 48. And you can see that we're using 2 columns basically like this. And that's what this is here. It's telling us which columns we should be using. So in this case, we're using columns 0 and 1 for the first frame, 2 and 3, 4, 5, 6, 7, 8, 9, all the way up to 15, which is defining this entire row along here. Now, what I don't know is where this number starts, because this is the character numbers up here: 0, 1, 2, 3, and that's fine. And the characters are pulled in 6 at a time this way. I just don't know exactly. I forgot exactly how they're arranged in memory. So this could be 16. It could be some higher number. So we're first of all, we'll just check that this is running, um, which means loading up the main file, giving it a compile, make sure it works. Put Aztec Challenge to bike. That would be pretty good, yeah. But I was thinking it'd be very, very simple to do. So, you could take a Raspberry Pi. It's a trivial task to write some kind of framework for it. I mean, you could even use JavaScript. You got Pixie.js. You could write something very easy with that, or you could use Unity or something like that, and you could just write some kind of front end for it, which you plug it into your TV. You plug your bike into it. You might have to do some calibration because the bikes might be slightly differently how they work. Or Python, yeah, you've got a Pi game as well, haven't you? You got lots and lots of choices of how to do this, but the essential thing would be you could create a little kind of like a multiplayer community app where you can basically play games and while you cycle. A long time ago, I set an exercise bike up to a keyboard, so I wired it up to a keyboard controller, which would basically press space every time the wheel went round once. And then I wrote something in. Can't remember what I wrote in actually. It might have been JavaScript. It might have been Flash or something. It was a long time ago. Um, uh, oh no, it was JavaScript. It was a media player. So I made a media player, and you gave it a video, and then what it would do, it would display the video on the screen, but with like a power bar at the side. And what it would do is, as long as the power bar was above the middle, the video would play. And cycling would keep the power bar up. So over time, the power bar would drop down, but cycling would keep the power bar up to a certain amount. If you cycled really fast, it would go really high. It would give you a couple of seconds to relax, and you could do it. But the idea is you had to maintain a certain speed in order to be able to watch the video properly. And I watched a couple of seasons of Dexter like that, and it was pretty good. Or if you slow down, it plays ABBA. Flappy Bird with pedaling to fly. Yeah, see, there's loads and loads of ideas for it. It'd be really good. And you think of the price of a Peloton, and then you think of the price of like a Pi Zero, or even a Pi 4. £50. Get an enclosure for it, probably about another £20. So £70, you've got something which you can put all this stuff on and it looks decent, and you could stick it to any bike. Doesn't need to be multi-thousand-pound Peloton bike. It could be £100 bike, as long as it's got a tachometer, speedometer, pedometer, whatever they're called on the bike, then it's enough. You just need to connect it up. You could probably provide an adapter kit as well, for a couple of extra quid, which converts various makes of bike to work with it. Um, and then the software. So you're looking at no more than £100 for all the equipment to make this work. Or the only thing you'd have to do is provide your own TV. But I mean, it's not exactly a difficult task to set your exercise bike up in front of a TV. Yeah, exactly. A lot of bikes have a jack. Mine has a jack. The last one I had a jack as well. So it's really not a difficult task. You just unplug it from the controller, plug it into your adapter kit that you've got for your Raspberry Pi, which would just be 3.5 millimeter mono jack probably. Yeah, onto a GPIO, and there you go. You got it. You got it working. Very, very easy to set up. You can have multiplayer races as well. So you could have like an in-game currency, kind of like shimmy shillings, where you can use it for cosmetics and things and stuff, but you can also use it to enter races. You enter a race with random people, and if you win, you get a prize, and you can see the other people racing with you. You can all connect over some multiplayer connection, or you can just go and play games, which could earn you these credits as well. Yeah, it'd be kind of cool. It'd be kind of cool. It just needs somebody to spend some time to do it, and it'd be a hell of a lot cheaper than buying a Peloton bike. Okay, so let's create a couple of new animations. So I'm going to create Perseus idle, and that's just going to be one frame, right? So the frame that we're looking at is the Mega65, yeah. And the good thing is only fat and fit geeks will be able to use it, so you wouldn't get shown up, yeah. But the reason I was thinking of it is because I find most kind of exercise bike stuff really mundane. I don't want to do it because I'd rather be doing anything else in the world. And it's not that I don't want to exercise. I do want to exercise, but I've got to be exercising for a reason. And to me, sitting on an exercise bike, staring at a wall, or even watching TV on it, I can watch TV on my ass, or I can sit on a bike and do it. Unless there's a purpose for the bike, I don't see the point. And exercise to me comes because I'm going somewhere. So if I have to go somewhere and I can walk, then I'll walk, and that's a bit of exercise, right? That's where it comes from. Exercise without any end goal other than to lose the weight is it to me doesn't appeal. So the idea of having something that gamifies the hell out of everything you do on the bike would make me want to do it. So even though it's still not, I'm still not achieving anything, I'm achieving virtual points, and it's that makes me want to do it. It's really sad that I'm like that, but that's exactly what I'm like. So okay, so we're going to add a couple of animations in here. Uh, and hopefully these will easily work. So what I want to do is I want to use this opportunity now to test out the animation system to make sure that I can trigger an animation at any point. I can cue an animation to happen after another point, um, and so on and so on. Walk to yeah. See, that's the thing. I don't have a dog either, so for me, I mean, I'm not going to attempt to walk my cats. That would be insane. Although I have seen people doing that, so yeah, that I'm not. I wouldn't be the first to do it, but I certainly don't want to walk my cats. Yeah, VR Beat Saber. This is one thing I want to do when I move. I think is get a VR machine again. I want to build myself a much smaller gaming machine. Keep my main desktop, obviously, but build a kind of slightly smaller kind of machine for the front room, and get the VR set up on it as well. Like a video driver. So one of the things I did with the old system with the videos is I had some videos of point of views from bike races. So I had like a point of view from somebody riding in a bike race, and I would put that on as well because as you would cycle, I had two modes for it. So I had the normal video playback mode where you had to keep the power above a certain level, and then I had a relative mode where if you cycled fast, the video would play fast. If you cycled slow, the video would play slow. And I put that on for the bike rides. It's pretty good. The other one I kind of liked as well was I had Street View connected up to it as well. So I had it set up so that if you had it Street View on, you could get it to basically advance, press the up arrow for you. Um, while you're in Street View every now and again, so you could like define how many turns of the wheel would cause it to move forward. I think it was like 20 or something like that would make you move forward one. And then you just pick somewhere like I tried to cycle from the outskirts of Vegas up through the strip and out the other side. So that was kind of fun. Um, right. Anyway, so there we go. We've got three animations now. So what I want to know is if I go into my player control file, which I don't know where that is actually. Player is here. Control. There we go. So the moment, what are we doing? We don't have anything. This is a very temporary. Okay, so this is temporary vertical movement. And then we've got some horizontal stuff. So So I think what we should do here is we should store some state. So just moving these out of the way. And this is our right movement. Now, I'm going to store control state in here, or movement state, I'm going to call it. So by default, it's going to be on 0, which means we're not doing anything. But what I'm going to have is I'm going to have a couple of constants here for various states. Okay, so I'm going to call it a PM state, player move state, and we're going to have walking left, walking right. So these are going to be our initial states. Now, if neither of those are set, actually, let's put a tab in there so it's nice and neat. There we go. If neither of those are set, and we should probably have an initialize in here to initialize these. So let's put that in. So at the moment, it's probably not going to do anything. Let's just call it init. Just keep it nice and short. Actually, it can do something. It can set 0 and store that in player move state. And then return. So that means in here, we need to also call that when we do all the initialization stuff. So let me just find where the inits are. Okay, so this is our main update. Here's where we initialize various things. So I'm going to do it in this section here. I'm just going to call control.init. Put these constants right at the top. So the idea is what we're going to do is when we move to the left, the first thing it's going to do is it's going to check to see, are we already moving? If we are already moving, then it's for now it's not going to do anything. However, if we're not already moving, it's going to change. It's going to set this value. Actually, let's think about this. Hang on. Yeah, it's gonna set that value. Actually, it's quite simple. We just need to, if we're walking left, set this value to. So okay, so we need to start by clearing this value again. We need to say, okay, we're not. No, actually, that's not going to work either because we need to know if we were previously moving or not. Let me think. Um, hmm. Okay, I think what I'm going to do, we need to decide what we were doing previously and what we're doing now. So we probably need to know the previous move state as well. So I'm gonna store that. Now the reason for this is because we do need to know, based on what we're doing this frame and what we were doing last frame, whether or not we need to trigger a turn animation, whether we just need to do nothing at all. So for instance, if we were moving left previously and now we're saying we're moving right, then what we need to do is trigger the turn animation, and then when the turn animation is finished, then we can actually start moving in that direction. So another one in here would be turning. Now when we turn, what I'm going to do is I'm going to keep this value in place. So this is going to say which direction we're currently facing in, but we're turning. So that will allow us to decide which direction, which animation we need to play and whether it's in reverse or not. Okay, so in that case, we also need to store on the previous state here. And that means in here now, let's just try and move this over, give myself a bit of room. we can start by first of all clearing our current state. We need to make sure our current state is cleared, but before we do that, we need to store our current state in previous move state. In fact, we'll do that. Yeah, we'll do that at the beginning, actually. Oh, why is that? Okay, so called previous state. So now we know what our previous state was, but now what we're going to do is we're going to clear our current state. No, this isn't going to work, is it? Hang on. It is a brilliant. I think it's such a good, cute doggy face. Look at it. Such a cute doggy face. Okay, I need to think about this. Because what I need to be able to do is work out what kind of animation we're currently in and what we need to do at the end of it. So let's not worry too much about the turning. Let's figure out the idle thing first. So we'll keep these in place, but let's have a think about this. Okay. So we're idling if neither of these are true. So if both of these are turned off, then we're idling. So let's start by clearing our move state, right? So we start with nothing going on. Then if we move left, move horizontal. Okay. If we move left, then what we can do is we can take the value that's in move state and we can add walking left. Actually, you don't need to do that. We can do. I've got to remember to do this all the time. So this is something those who've been doing Mega65 this week will have probably learned. I think I've talked about it a little bit in the chat. This is setting a bit. It's much easier than doing or and all the time. A bit quicker as well. So you take the bit that you want to set. In this case, the value that we want to set, which we've already got set up here. These values here. And then you just say set bit, test and set bit. So we do that here like that. So now we have a state which is saying whether we're walking left or right. So what we can do is we can use that information. Let's do control. Yeah, let's do. Hang on, let's have a look. What have we got in here? We've got. Does that only work on 0-page variables? What, TSP and TRB? No, it works on anything. They're not 0-page at all. These are right in the middle of RAM. TSB, TRB work anywhere you want. They're just like and basically. It's just a kind of combination function. They work like the ands and ors. So we've got animations update here, which will update our actual animations. We've got control update. And this is a framework update. This is a player update. So okay, so in that case, what I'm going to do is I'm going to call a function here, which is going to be update player animations. So the reason I'm going to keep this separate from this function is I don't want to complicate this function, and I may move this to somewhere else. But for now, I'm just going to keep it in here. Spider-Man background, good. Isn't there something like that only works in 0-page? Yeah, there was the branch and test or something. So BR7, BR6, that sort of thing. I can't remember the exact thing, but yeah, there is that. So which I thought I was going to be clever by using. It turns out it does only work in 0 page. So, okay. So first of all, let's spell animations, right? So what is this going to do? This is going to take our you got AMK points for that. Yeah, you did at the time. Yeah, I remember. I think they were imaginary though at that point. So we're going to take our move state and we're going to compare it to our previous move state. And if it's different, then we need to do something. If both of these states are the same, then we don't need to do anything, right? If we were walking and we're still walking, we don't need to do anything. The only time we need to do anything is when the states change. So let's put a little note in here to say, check if player move state has changed. And so if it has changed, then these won't be equal, and we'll jump ahead to here. Otherwise, we will return. So at this point, we know something has changed. So keyboard's in the way there. Let's move that over, nudge it over. There we go. Oh. Okay. So this is where we can now check to see what has changed, right? So this is let's start with what is that? That looks interesting, whatever it is. I like the look of it. Take a play move states changed. Okay, so yeah, so what we need to know here now is we're going to check for has walk direction changed. So for now, because it's the only thing we're testing, we can just say, well, if something has changed, then walk direction has changed, right? So for now, this is going to be super simple. But as we start adding other properties in, we're going to have to change what we check in here. We're just going to have to check things a group at a time. So let's actually put that check in now, so that we don't confuse it with the other stuff that's going on, or that might go on later. So let's take our value, which we already have. We already have this. So we're going to end that with. We can take the player move states. We can probably just type this number in manually, but I think it makes more sense to take the two walking states, right? So now the accumulator contains just the walking states. I am going to push that into. Oh, actually, I'm going to store that in. Compare walk, I'm going to call it. And then I'm going to do the same thing by taking the previous move and performing this again on it. And then compare that with. And if that is the same, that means that the walking state has not changed, right? So we can quit. Otherwise, at this point here, walk state has changed. So now we need to decide what we're going to do here, and we're going to do that by actually, should we be doing this the other way around? We should probably be doing this the other way around. So let me just swap this around a little bit. So I'm going to get rid of that, because the reason I'm doing it this way around is so I can keep hold of the value that's in move state to do the tests here. So all right, so let's put some little labels in here. So left, right, and idle. Call this skip. Let's change that to skip. Okay, so in these points, we're going to do these comparisons. So we're going to compare if we're walking left, compare if we're walking right. Otherwise, we're doing neither and we're in idle mode. So if we're walking left, so if we're not walking left, we jump to right. If we're not walking right, then we jump to idle. Otherwise, what we do is we change the animation, and we've already got the animation stuff set up in here. So you can see set animation now. So we'll go with set animation now, but we probably want to change this to be set animation kind of next sort of thing. I think, I don't know, we'll have to see how it works, but let's start with set animation now and see how it works. So set animation now. Okay, so we need to work out one of these attributes is going to be flipping it, and I can't remember which one it is. So let's have a look what set animation now does. Let's have a look. Set animation now, index, animation pointer, speed, and frame. Okay, so that's actually just a speed and frame. So okay, so that's set animation 0. Okay, so let's create let's create some animation. So in animation config, what we can do is we can create some more constants in here. So I'm going to create animation index, or AI. I'm going to call it player, and that's going to be 0. And then I can use that whenever I use 0 in the indexes in here. There we go. So now we're setting those by using a reference to our player, and we can set all our constants in here. So this retains our animation config file as the source of truth for all these kind of constants and stuff. So in our control, okay, so we're still setting a run animation, but we are changing attributes. I think that's all we need to really do here. So I'm hoping there is an attribute, set animation attributes. Here we go. Okay, so we go in here. Sorry, in here. Set animation attributes, AI player, like that, and the attributes are somewhere around here. Bit 7, bit 6. Wait, did we not set them already? Hang on. Animation. And are we turning them off or clear animation? Okay, so we're just okay, so we keep the animation attributes and we just turn on the one we want. Okay, so, and those should be horizontal flip. Okay, so this is running right, so default is running to the right, so that probably needs to be clear animation attributes for that one. and set animation attributes for that. Right. So now we're already doing that. You can see here we're already doing this, but that's being controlled somewhere else. I think that's being controlled in here. Yeah, see, it's being controlled there, and it shouldn't be being controlled there. This is just our control, so we can get rid of that now, and hopefully that will happen as part of this routine. So all I need to do at the end of this is jump to skip. And then this animation should be idle. Now, hopefully it retains the attribute. So we need to make sure that it retains the attribute from previous. But hopefully if that works now. Oh, that's a weird one. What's that? What is that? Hey, CJ Halvala. What we actually do, new guy. Oh, yeah, welcome. Working on animation routines tonight for. Oh, it is. It's Cyclone, isn't it? It is. It's Battlestar Galacticus. It's a weird Cyclone. It's a weird Cylon. Sorry, not Cyclone. I'm reading Steps' thing. Yeah, Cylon. Yeah, just working on animation routines. So, oh, why is it not reading that? Do I have to get that from? Oh, I need to do animations. Okay. The red Cylon. Yes, we do, don't we? What's he called? Oh, I can't remember. Something 8. Wasn't he number 8 or something? I can't remember. Number 8 seems to ring a bell for me for some reason. Okay, that's the wrong way around, but it is kind of working. Oh, you see how when I stop, it stops. 6, that's it. 6, yeah. That's me right in Red Babe, yeah. She was, yes, number 6 of some kind. Oh, because this is left and right. I've got these the wrong way around. Okay, that's fine. So this should be set. And this should be clear. Now, obviously, at the moment, what's happening is when the game starts, it starts off running, and that's because the default state is 0 in here. So what I probably need to do is set the default state to be everything enabled, and then when it goes to do the comparison, it will find that there's a difference, and it will apply the right animation. So if all goes to plan, did that not build? What did I do? Did I make a mistake somewhere? Oh. Oh, there we go. Play move state 5. There we go. It's quite quiet tonight, actually. It's probably only about half the people we normally get on stream. Yeah, the webcam does look a bit there. There we go. A bit more on my head. There you go. Is that a bit better? I think that's more like the normal shape in my head. Yeah, there we go. So you can see now it's working, and if we turn, so we've got the animation system kind of mostly working now. So we can add the turn in now. So this is where we need to add a new kind of I wonder why it's. Oh yeah, is that still? That's a good point actually. Is that still going on? Is transmission still running? I don't know if it is or not. Probably. I mean, it's a bit quiet though tonight. It's unusually. Seems quiet in chat as well. I don't know if it's. I mean, Steps is here. Okay, everyone is in the pub. That's a good point, actually. Yeah, that's a very good point. I still can't bring myself to go out. I just can't do it. Hey, Thalamus is here. There we go. How you doing? How you doing? Well. Oh, what's that background? Oh, Predator. Did lockdown end? Well, kind of. Okay, so the animation system needs the ability to trigger an animation and know when it's complete as well. Like it needs a callback or something. Okay, so what I'm thinking, first of all, we need a new animation function, right? So you see here we've got Perseus run is the animation that's being started. What I'm actually going to do is I'm just going to turn off the update player animations for a second. And because I want to try creating a new system in here, right? So this is going to set an animation up, and then I want another one. So this set animation now. Let's just move this over here, actually. I'm just going to knock the font size down by one because it's getting hard to read it all. Is it chocolate mousse? Commando. Ooh, that gives me an idea for a trolling background. No, that would be too extreme, I think. Probably terms of service. Yeah, no, I was thinking no pants on. Just a picture of someone with no pants on. What does the game do so far? Not a lot. I'm working on framework stuff at the moment. It's really just an engine for animations and stuff. There's really not a lot going on. It's more to do with the core engine stuff. So I haven't touched it for a little while. I haven't touched it for probably about a month. So just trying to get back into it, trying to work these animation systems out so that I can create very, very complex kind of combinations of animations, but with a system that is reusable and easy to use, which is what these macros are about now. So I've got set animation now. I think what I want is I might have already created set animation on frame. Yes. So this is what I want, right? I want the ability to, at a particular frame of the previous animation, start this animation. So let's have a look how we would write it, right? So just going to expand this over here. Hopefully you can see. Oh yeah, you can see all that. Okay. So if we take this and duplicate, right? So this is launching an animation. So this is saying, take the player. Our sprites are actually called animations in this. So animation is a collection of raster rewrite buffer sprites that has position, frame data, and frame and animation attributes like whether it's looping things like that, and that's how we get these kind of sprite kind of things. So what we're saying is take the player, which is this is a number, this is an index, this is like setting sprite 0, but we're using constants for it. So we're saying take animation 0, the player in this case, apply the run configuration to it to set the animation at speed 7. Not sure what that one is for. Let's have a look. What is that? Oh, okay. Starting at frame 0. So this will almost always be 0 anyway. Okay, so we're saying play the run animation at speed 7. from frame 0. But what I want to be able to do is on this new one is set animation on frame. So what we would say here is we do the same thing again almost, but we have an extra property at the end here. And this property would be when the current animation is on frame 4 or 5 or whatever, right? Now, that means we'd need to know what the previous animation was. So the sensible thing here is to provide two methods for doing this. First method is a direct frame number. So we can say, okay, when it gets back to frame 0, or we can set a minus number, which would be how many frames from the other end it would be. So we could say 0, which would be right at the end of the animation. So when the last frame runs, like so. So display the last frame, and then instead of displaying this frame, frame 0 of this animation, it would move on to the next one. So I'm actually going to try it like that. I'm going to try doing this. Set animation on frame, and it's going to set some values in here. All right, so let's just start with the forward numbers. Let's not put minus numbers in. Let's just go with this one. So it's exactly the same data, except we have trigger frame. Now, it also means that we need to store these values, right? We need to store what the next animation is. So that means in our animation data in here, we need some additional information, which needs to store 1, 2, 3, 4 values. Frame speed, no, 5, because we need the trigger frame as well. Okay, so we need 5 values. So let's call this next speed. Is it next frame speed and pointer low and pointer high? Let's call it next anim speed, next anim start frame, next anim pointer low, next anim pointer high, and next anim trigger frame. So actually, the trigger frame probably has to by default be negative. So that it gets ignored. So let's put these in. Okay, so if we're going through our animation, whenever we advance to the next frame, we also need to check into this section here to see, do we need to change animation, right? And currently we're not doing that. So we would have to check something in here. Now, the problem is what do we check? We could check. See, this is likely to be 0. This is also likely to be 0. This could still be 0. This could not be, but I don't want to check random things in here. I think we're going to use the negative thing to change here. I think most animations are going to trigger at the end. So setting a 0 by default is probably the right thing. There may be a couple that trigger at very specific animation points. So I'm going to go with the default of this being negative here. Which means anytime an animation starts, this has to be cleared back to FF. So that means when we do this thing here, no, not this thing here, we also need to set this. And that's to ensure that if we force an animation to play, then the next animation is not going to get triggered because we're forcing an animation to override. Set animation now overrides any kind of queue that we've got set up, and it's not really a queue because we're only queuing one. If we wanted multiple, we'd have to make this data array much bigger, which for now I don't think we need. But if we do need it, then I will extend it. But this is already going to take however many bytes. It's going to be 32 times 5, so it's not that many. It's 160 bytes, but there may be a need for more. So we could kind of fill this out with a bit more, so that there is kind of multiple frames of animation. This could be put into something different, so we could actually have a queue list that we pass through every time. But this is going to be the fastest way to access it. I think having a stack of kind of queue items that might make it convoluted and a bit tricky. Oh, Jaws! I like that Jaws background. It's good. Okay, so in that case, let's work off the assumption that this is what we're checking, and that this trigger frame, if it's not FF, then we need to check it against the framework that we're on. Okay, so let's have a look. This is where frame is advanced. This is what's doing the actual advance of frame. Okay, so you see we're taking the frame number here, we're storing it at this point here, store data animation frame, which seems to be the only place we're doing it. So interesting. Complete vector. Ah, okay. Oh, I see. I prefer that method, actually. I prefer that method. Yes, I prefer that method. All right, let's go with that. So, what do I mean by a complete vector? So, anybody who's used any kind of high level language will be familiar with the concept of callbacks, right? Um, so, we're going to create something like that. We're going to have a callback vector in here. And instead, what we're going to do in here is instead of passing oh, actually, we do need. Oh, yeah, that means we don't actually need this at all. What we would do instead is we'd say set animation callback. Let's call it complete callback. It's a long function name, I know, but and then we set that like that, and then we create a pointer to a function. So we'll say let's just put a temporary function in here somewhere. Oh, we've got these method 1 and method 2. I don't know what the hell they're about. Okay, don't know what they are. Probably find where that's being used, because if it's not being used, that's a really stupid thing to have in there. Oh, it's the interrupts. Okay, yeah, I can get rid of those because we fixed that. I'm not sure if we sorted. Don't think I added a sort in for these. Yeah, to do sort interrupts, so we've got to do them at some point. All right. But here we can have like a player turn, and then the player turn can actually do this thing. Okay, so what this is doing, we set an animation, and then at any point we can say, I want to set a complete callback. So when the animation, the current animation that's running on player is finished, i.e., when it gets back to 0 again, then jump to this function here, and this function will be set animation. Now, is this myth? Sounds like myth. Like that. And then in this, you can also say, and when this animation is finished, do something else. So actually, this is going to work out quite nice, I think. So do I'm gonna do two things here. So I'm just gonna try and set these to alternate. And this should be a good test of this system. Okay, so we're getting two callbacks. So I need to create this function. So I can probably get rid of this set animation on frame. I don't think that's necessary anymore. I will. No, I'll get rid of it. I don't think we need it. Instead, we're going to have set animation callback. So we're going to have index and callback vector. And then that means in here we don't need all of this. It also means we can chain more than one together, as we're doing now. We can create a callback chain. Complete vector LSB. Because we don't need all of that. Now, in this case, what we will do is we will check the most significant byte to see if it's 0. If it's 0, that would imply that our complete vector is in the 0 page. That's never going to happen. So we're not going to. If this value is 0, we're going to assume that the complete vector is not being used, which means we can just put 0 in here and change that to like that. So now, whenever you start an animation, this gets cleared to 0. So the complete vector. So if you start a new animation, the clear vector gets cleared. And then here we say, okay, we take our callback vector low byte and store that at if index equals null, load x with index. Otherwise, we take the x that we've already set, so that's fine. Like so. That should be LSB. Cool. Right. So now we can set a callback. So that means when we come into this, we have to check here if we've completed. If the animation is completed and the vector, okay, let's take a look at this. Then launch complete vector. Okay, so this is our complete function. And this is where I've already stored the animation frame in here. Okay, so how do we know if it's completed or not? Well, it's completed if the animation frame is on 0, right? So if this is an animation and it's complete, it will have hit 0 again. That means if we're just doing a normal loop, it will just go all the way around, and once we get back, once we've gone once through the entire list, it'll hit 0. If it's a ping pong, it means it'll go all the way to the end and then back again. Why doesn't your animation routine just check for a value like F at the end of an animation sequence? Because the animation sequences can be all sorts of weird things. So you can ping pong loop or you can do a full loop. So we also have a frame 0, so it's just whenever it hits 0, really. So cheers, Anton, for the bits. Very much appreciated. Drinking cider tonight. What are you guys drinking tonight? I'd like to know. I've kind of wimped out a little bit. I felt very sick after the alcohol last week. Yeah, so just to continue with the question from Thalamus, milk. I've drank a lot of milk this week. I really have. I don't know why. I've got some weird kind of milk fetish going on. I've drank a lot of milk. I probably drank about 8 pints, maybe more. I drank a lot. Drank a lot of milk this week. Maybe more. Maybe 10 pints. It's been a lot anyway. I don't know why. I don't know why yeah, green top milk. The semi-skimmed stuff anyway. Rheinhessen white wine. Ooh, I don't think I've had that. I do like German white wines. Last week I had a Riesling, however you say it, and it was a nice one. It wasn't one of the really sweet ones. It was quite a dry one. It was nice. I don't drink white wine that often anymore on stream. I used to always drink it, but yeah. So to go back to the question from Thalamus, the thing with the animations is this is how the animations are configured here, right? So I know when I've reached this end point here because I have this counter here, so I know when I've reached it. But I'm able to run this animation in a number of ways. I can run it so it will get to the end and it will stop by turning the loop flag off. I can run it to the end and have it loop back round to here again when it finishes. Or I can have it ping pong, which means when it gets to the end here, it will turn around and go back the other way. I can also play it forwards or backwards, and this is all just done through the animation attribute system. So the number of different ways to go through this are quite different. So in fact, actually, even using the frame zero is not going to work. What I actually need is in here when there is some kind of loop flag that gets hit. So when something says, okay, we're at the point where we've the animation has looped. So you can see here we've got a couple of things that change, right? So um, so at this point here we've hit the end. Oops, for God's sake. So this is cycle complete if we're running backwards. And this is cycle complete if we're running forwards. And then ping pong just decides whether we're running forwards or backwards. So actually, these two positions here are probably the right place to set some kind of flag. Now I just need to make sure. Oh, there's also pause. You can also pause an animation as well. So there's loads of different ways to run these animations. Because what I'm trying to do, yeah, that's exactly what I'm trying to do is create a generic framework. I'm not trying to do something that's specific to my game. It's something that I need to because I want to share this file when I'm done. I want to share this whole kind of layer and animation and kind of sprite configuration system, so people can take this code and drop a couple of configurations like this and use a couple of scripts for as sprite and create something like this very very quickly. So I'm trying to do all the groundwork to make that as flexible as and efficient as possible. Um, so far it's working quite well. I mean, it's slow progress because I've not been doing very much on it recently, but now that Saturdays are dedicated to this, should start seeing some progress with this. Um, but the framework's already pretty strong. I mean, the layering framework is really good. We've got a nice little debug panel down there, so you can see that panel at the bottom with the numbers in it. That's all just done with sprites, and that's another little add-on that you can use. The sprite system itself is strong and can do a lot. I mean, 28 sprites on a row of this size is humongous. It's way more than we would normally expect on a system of this kind of generation, if you like. And it's going to be more than enough for this game as well. Okay, New Zealand makes some cracking white wine. They do. Most of my Chardonnay Sauvignon Blanc comes from New Zealand. So could the Mega65 in theory do transparency? I think there is an alpha blend mode in it. I can't remember how that works. I haven't used it. But I guess you could probably use the alpha blending to do something like that. I haven't got round to looking at it yet, um, so possibly. I don't think it's built in inherently because the colors are just 23-bit, so RGB, not RGBA, RGB 788 rather than RGBA. So it doesn't have alpha transparency built in, but there is an alpha blending which may be able to simulate that somehow. Though I haven't had a proper dig into it to see how it works. Um, but I imagine it's some kind of weighting between. Yes, I think so. I think when you blit a layer over the top, I think there's a way through the alpha. If it's like typical alpha blending, then you can look at it's weighting the amount of the pixel that's on the screen currently versus the pixel you want to draw. So normally, what normal kind of blending, the standard kind of blitting that we do is 100% of the pixel you want to draw and nothing of the one it's going to cover. But there may be a way, I don't know exactly how it works, where you may be able to define the weight between the two. So you could say 50% of the pixel I want to draw, 50% of the pixel that's on the screen already. And that would create a transparency thing. But I don't know if that would work directly in hardware, or if you'd have to do that manually. I mean, you could definitely do it manually as well. Probably not in this mode, though, because I'm in 16 color sprite mode, well, 16 color character mode. So even though I have 512 colors going on the screen, there's only 16 in any character block, so it would be a bit weird. Uh, but yeah, I mean, there's loads of ways you could kind of simulate it. I think so. I've definitely seen it in the manuals. So there is Coloram Byte 0 bit 5 says alpha blend mode, which may have something to do with it. But I think because the very basic alpha blending is what you see now, which is if a character has no pixel in it, then it keeps the pixel behind it. Without any form of alpha blending, you would just get a black box, or you'd get color 0 around the character. We do have transparent pixels, but they're fully transparent. They're not semi-transparent. So I just wonder if there is a way to kind of to do that through the alpha blend value, whatever that might be. What's the refresh rate? Can you choose 50? Yeah, you can switch between PAL or NTSC. I'm using PAL just because that's what I'm used to. But yeah, I mean, you can set NTSC as well. So, um, okay. So this is the cycle complete bit. So what I probably need to do is set a flag when I get to this point, right? Which I can probably do. No frame advance. Okay, which means we would come to here. Otherwise, we come into this section here. Now, can I use the Y register? It looks like I can use the Y register in here, but I want to be sure before I commit to that, because I don't see anywhere else where the Y register is being. Oh, it's been used there. That is the only place it's been used, though. Okay, in that case, we're going to set is complete, right? And then what we can do in here very easily is we can just say increase Y and increase Y. And now if Y is set when we get to this point, then we are complete. So here we go compare Y to 0. I know it's stupid, but we need to do it. I'm going to put a skip in here just in case, because I know we could jump to this, but I'm not sure if I'm going to need something else after this. So I'm just going to make a branch called a label called is complete, and I'm going to jump to that. So if that is equal to 0, then I'm going to jump to skip complete. So the reason I have to do a compare Y with 0 here is because I don't know. Well, actually, I do know the accumulator was the last value to be read in. So the 0 flag will be set based on the accumulator, not based on the Y. So I do have to do the compare Y to 0 here. So this powerful bastard comes along here. Yeah. So one of the things, and definitely one of the things that was used a lot, definitely in the early demos I've seen on the Mega 65 was launching from C64 mode. So you can boot into C64 mode, but then you can use C64 mode to enable things like the VIC-4 or the quad SIDs or things like that. So you can still do Mega 65 style stuff, but from C64 memory space and C64 kind of boot systems. I'm not doing that because I want to kind of write stuff that feels native to the Mega 65. And I think if you have to boot into Commodore mode, into C64 mode first, it's not going to feel native. And I'm trying to avoid that kind of that jarring feeling of kind of having to. I don't want to be in the situation where people, the first thing they do when they start the Mega 65 is type Go 64. This isn't a this isn't the this isn't the Commodore 128. There's a reason to be starting in Mega 65 mode, and I want to make full use of that. What is the point of booting C64 first? I think it was just easier because obviously the memory space is different on Mega 65. So things like Exomizer and things like that will work perfectly in C64 mode, but will struggle in Mega 65 mode. So sometimes people would boot into C64 mode just to kind of to bootstrap their Mega 65 stuff because, as Talamy says, it was comfortable here to play to play old games. Yeah, of course. But I'm trying. That's what I'm trying to change. I'm trying to get people comfortable with this mode. Also, the banking is very different when you come from C64 mode. So your initial setup is a bit easier in C64 mode because you can just use the normal C64 banking. You've not got a C65 ROM in the way. You've not got although you will still have to turn off the read only for it, but it won't be banked into C000 like it is on the Mega 65. Um, so yeah, the setup's a little bit easier coming from C64, but it's just because people aren't used to doing it on the Mega 65, and that's what I'm hoping this is going to do, get people used to that. So okay, complete vector. Obviously, this needs to be set up. So I'm going to make that a self mod like so, and then we're going to load that value in. So we know that it's in data, and we know it's called complete vector. Is that the one? I hope so. Hopefully, I kept that name. Complete vector MSB and LSB, of course. I've lost where I am now. Damn it. Here we go. Store frame. There we go. Come X and store that at complete vector plus 0. Now, obviously, this should only work if this value here, so we'll do this one first, is non-zero. If this value is 0, then we're going to skip the complete, because if that value is 0, it means we've not set a complete vector up. Thank you, Sparky07, for the follow. Very much appreciated. Welcome to the stream. In other news, we're down to the last 5 episodes of Frasier. Do you know what I started watching again? I'd forgotten that I hadn't watched most of it. Bob's Burgers. So I was watching something, and John H. Benjamin came on it. And for anybody who knows who that is, he's the voice of Bob in Bob's Burger, the voice of Archer, the voice of the shop guy in Family Guy as well. Very, very well known voice actor, and he just uses his own voice, and it's an amazing voice, and you cannot miss it. But I was watching something with him in it, and I thought, bloody hell, I've not watched Bob's Burgers for a while, so I checked out how many seasons. It's on 10 seasons. I think I've only watched 2. So I'm enjoying kind of working my way through that. It's kind of nice. Actually, I was started on season 2 because I wasn't sure how much of that I'd watched. And the episode I was watching, he had an arcade machine in his shop, and the font that was used was the proper arcade, the proper Capcom arcade font, which I really really liked. Um, oh my god, you've only seen 1 season of Archer. I'm so jealous. I'm so jealous. That's I wish I had only watched 1 season. You've got what, another 9 seasons to watch, and they're amazing as well. Every single one of them is amazing. So it does worth prices. Yeah. Fellow Vic 20 and C64 fan here. Cool, cool. So you'll probably like this then. So we're working on the Mega 65. So it's a new Commodore thing. I'm sure somebody can. I can do it because I've got the new thing there. There you go. So it's a new Commodore computer, but not Commodore computer. Oh, there we go. Um, Tech demo. Oh, the Turrican thing. Yes. New games and new software. It's probably not. Yes, and I think what we're going to do occasionally on this stream, we're going to do it next week. Is I don't know if you were here when I mentioned this, but I'm going to take some of the games that viewers have made for the C64. If they want me to do it, I will take their game and I will convert it to Mega 65 with new graphics and stuff, so it will run natively on the Mega 65 rather than through C64 mode. So we've got our first one with Warlock's kind of Game and Watch game, Toxic Frenzy, which we'll do. Which we'll do next week, I think. I just need to have a look at how the graphics work, and we'll do that. So, um, you've not seen any Archer. I got hooked on Rick. I can't get into Rick and Morty. I keep trying. I just don't get it. It just doesn't seem funny to me. Seems kind of childish and not that funny. I don't get on with it. I can kind of see where some people might like the humor, but it's just not my thing at all. But yeah, if anybody does have any Commodore 64 games they want me to convert to Mega 65, I'm happy to do it. My only stipulation is that if I convert a game to the Mega 65, it's for free for people to use. For people who own a Mega 65, it's a freebie that goes on their thing. I don't want to. I don't want to spend my time doing something that then is going to sit behind some kind of paywall or something. Everything I've done so far has been free for the Mega 65, and at least until the end of the year, it's going to stay that way. Um, for my stuff anyway. So uh, didn't know about the M602s. I'm not a coder, but I enjoy games very much. And the real keyboard, yes, it's got an amazing keyboard. Uh, Ignore the humor; it's the cleverness of the episode. I will. I mean, it won't be. It won't be the last time I've tried this. I'm pretty sure I'm sure I've tried to watch it 3 or 4 times and I never get anywhere. So sends all the Thalamus games to challenge. Well, if you want me to convert one to Mega 65, I'm happy to do it. They don't take that long to do. Um, but as I say, I'd like them to be kind of a free kind of download. It's all about promoting the system, so it would be something that would be free to download for anybody that has the Mega 65. So for fuck's sake. Yeah, at least for now anyway. I mean, next year when the machine kind of goes out, which could be sometime next year, or it could be this year, it could be next year. I don't know exactly when. But when it actually goes out and it hits the market, then that's a different matter because that's when we start needing to have kind of published games. So rags to riches. I don't know how cool looks with the copyright. There's no big company behind it. If you can get permission to do it, then I'm happy to do it. I'm definitely happy to do it. I don't think these conversions are that difficult to do. If you can find a Commodore, and it has to be a Commodore 64 game, obviously, it's converting something from another platform is just going to be too much work. But a Commodore 64 to Mega 65 conversion is quite a simple task. As I say, it probably took me no more than about 8 hours total time spent on the Luma game, and a lot of that was drawing graphics as well. So Luna, yeah, Luna's not a bad idea actually. That's a good one. That is a good one. That would work really well. Ooh, yeah, yeah. I might have to do that actually. That's a good one. Yeah, but yeah. If you've got permission to convert a game, or you own the game yourself or whatever, then let me know and I will um I will try and convert it if I can, and I will do a stream on it as well because it's really good. Good thing. I have thought about Luna before, but I was thinking of kind of doing it from scratch. But actually, when I think about it, it would be such an easy convert to do. That will have to be done. Yeah. Okay. All right. Let's crack on with this. So I think now this should we get to this point. If y is 0, we don't do anything. If the MSB is 0, we don't do anything. Otherwise, we store it. We store the LSB, and then we jump to that location. And then oh, and then at this point, it's almost like we need to jump to this because set positions, set new pointers. Oh, I'm not sure actually. Maybe this will work. All right, let's try this out. Let's try this out. Okay, so let me get my main file. Okay, so what we're doing is we're saying start the run animation, and then when it's finished, start the turn, jump to the turn function, which is here, this turn method. Then this method says start the turn animation. When it's finished, start the walk animation, go to the walk, and this starts the run again, and then the turn. And it should cycle between those two. So I'm hoping to see is this animation trigger between two. I mean, the direction is probably going to be wrong, but we might actually see. Press the right buttons. One animation trigger after the other. That's the whole point. Okay, so we've got an error somewhere. Let's figure out where that is. Okay. Unknown symbol skip complete. Okay. Oh, because it's capital. Okay. There we go. Yeah, if I do the Luna port, it will just be direct. I'll just basically take I'll just take the C64 code, make it run first, then once it's running, work on improving the graphics and stuff. Luna would actually be a really good case for graphical improvement as well. I'd probably go with full color sprites on that as well. Because while I can use the multicolor sprites, I think it would make more sense to use proper full color sprites in it. Or they'd only be 16 by 16, but they would be easier to set up. Relative address is illegal. Okay, so here's where we get to use one of the funky new things, which is long branches. So 45 GSO2 also has absolute branches as well as relative branching, which makes long addresses nice and simple. So same again here. We've got another one here, line 218 in animations, which is this one here. So normally we'd have to kind of invert the conditions, but now you just have to put an L in front of the branch, and it becomes a long branch, which basically turns it into a absolute instead of a relative address, I believe. Anyway, I've not actually looked at the output, but I'm pretty sure it'd be. It would make no sense for it to be relative still while it's 16-bit. There we go. We're running. Yeah, 4-char opcode is a bit weird. And there we go. You can see it's running the callbacks. Now, actually, it looks like it's not running the full turn animation. It looks like it's only doing part of it. So let's just have a quick look at the animation. But you can see it's definitely using callbacks. Ah, okay. So what we're getting here is it's only showing part of the. Yeah, it's only showing part of the animation. It's stopping at this point because it's not displaying the very last frame. So I think what we need to do here is we actually need to move this complete check to happen here after this lot here. So what I'm going to do is I'm going to take this bit. No frame advance would be here. Okay. So actually, that's probably not the best place, the best way to do this. So instead, what I'm going to do, I'm going to keep using these 0-page things. They're really good. Not 0-page, these self mods. So what I'm going to do is I'm going to do it here. So I'm going to do is complete. I'm going to put this down all the way down here. And then I'm going to move this all down to here. Like so. And now I can just use this value instead. So I can just do ink is complete. Ink is complete. And then this can be set. Attribute enable. So if it's not enabled, we come to here. This sets this up. Transfer SD accumulate. Okay, so we do it here. So we load accumulated with 0. Cool. There we go. Luna 65 could be the next long stretch. I don't think it would take that long to do. I honestly think Luna could be done very quickly as well. Grabbing parts of the wrong animation. I think what's happening is it was going through the animation. So it's playing through this animation. When it gets to the end, it moves into the turn animation. But what's happening is it's running up to this point. So the second to last animation. Then it tries to go to this one, and it says, "Oh, I've completed now," and it should then display that, but it's not. You can see what it's doing is it's stopping at that one there before it goes back, or it's displaying one frame more than twice. I need to take a look at what's going on. Let's try and run it again. Because it does seem to pause as well at the end. You want 68 hours of 68k. I think it'll be a while before I do a marathon 68k stream. I've got to be pretty confident. Oh no, that's not that's doing the same, isn't it? Although it seems to be pausing less now. Let's slow it right down. So we've got some animation speeds that we can set. So let's set these to slow down a little bit. So okay, so man, that's really slow. So I'm just looking at this. It does seem to be doing all the animations. I think it's just happening so fast in one case. So the next frame should be the last run frame. Then it should switch to turning, which it is doing. Okay. I mean, that looks correct. Let me try speeding up. Maybe it's just the speed that's it's going at. Maybe it's just too quick for it to be. Let me just put it down to 6. instead of 7. There she is. C64 Perseus. That would be good, but I think the sheer number of animations and stuff that it's going to need is going to be way too much. There's something weird about the speed of it. It gets to a certain point and then I'm not sure what it is. There's something not right. Because the callbacks are working. The callbacks are definitely working. We're seeing. Okay, what I'm also going to do here is just a temporary. So this is all temporary code here. And then what I'm going to do here is I'm going to take this value. I'm going to EOR it with 0, 1. I'm going to store it back in player direction. And then if I mean, I'm pretty sure this. I always get these sort of things. If I've got a choice of 2 ways of doing things, I'll get it wrong the first time. No, this needs to be set, doesn't it? Set animation attributes AI layer animations dot h. That doesn't feel right. There we go. No, it should be comma. Okay, so that needs to happen. Have I got this? I'm not sure what's going on now. Rags to riches. I don't remember rags to riches. I need to look that up. Science Square action game released in 1985. Published by Melody Hall Publishing. I assume it's a single load game. I assume it's not a multi-load game. Holy shit, is that old on me Petsky? It looks Petsky-ish. Okay, interesting. Okay, so I think this was right, but this needs to happen in here instead. We'll do that at the end, actually. That's super big sprites. Yeah, I see that. It is all pesky though. That's crazy. I mean, that would be pretty easy to convert in that case. See, yeah, there's something odd with the last frame for some reason. So let's just check that the animation works. So we've got a turn animation in here. Let's just have a look, right? So I don't know why that frame is not showing. There we go. So you should have 1, 2, 3, 4, 5 frames, which we do. We have 5 frames. In fact, where's the other? Oh, wait. 2 of these frames are exactly the same. That's a problem. All right. That's a problem. All right. So we've got 1, 2, 3. That was the frame that was not being put in properly. No, that is the frame that's put in. But this one wasn't. Okay. God, why does it do this? It's really weird. Yeah, that's okay. That's the one that we need. So I need to get rid of that one. Two, three, four, five, and then it should go back to that one again. So I kind of need to show. Yeah, maybe I do need to have that, but the other way. Because it's kind of part of the animation that he ends up on that position as well. So I am going to put that in. Actually, I'm going to do it from there just in case he's changed the light and there might be some weird lighting thing about it. Why? Why does that happen? I don't think there is a lighting change, but just in case. Okay, so 6 frames now. So save that file, come into here. So we go into our animation config and we can just add an extra frame in here. I don't know why those are still there. They shouldn't be there. So 26 and 27 are the 2 strips that make that up, which adds 1 more frame into the turn. Okay, let's give that a quick try. Hopefully that will look a bit more solid. I'm not sure. Yeah, that feels better. Okay, so now what with that knowledge, what I should be able to do now is make this work properly with the walk and run and stuff. So I'm going to leave that there as a kind of a backup. For now, I'm going to put this into idle, and I'm not going to have anything in the complete callback. So then in our animation, if we do control update in here, so we've got this. So this gives us the 2 different states. So the only other thing I need to do is if we are walking in a direction, but we're still turning, then we don't do So update. So left and right. So there'd be no left movement or right movement. I'm going to do these separately though. If PM state turning is there. So what we should be able to do here is you should be able to set these states like this, and then you should just be able to do bit against player move state or previous move state. Sorry. So if we were turning before, then we don't accept any horizontal movement like that. So if that's LT, there we go. So that should prevent us from moving while we're turning. Then in the animations, what we can do is we can say, okay, if direction has changed, if our walk state has changed, then we need to do return animation first. So what I'm going to do is I'm going to put player. I'm going to call this player turn left and player turn right. So this is what happens when we turn left, right? So here, instead of doing this, we'll move this down into here. And we'll set that to be idle, because when we finish turning, we want to go into the idle animation until we actually pull in one direction again. So that's what we're going to do here. But up in this section up here, what we want to do is we want to do Perseus turn. Now we want this to be pretty quick. 7 might not be the quickest. Let's just have a quick look at how many animation speeds have we got. 0 to 8. Okay, 8 is the fastest. Okay, so we want that to be quite quick, I would imagine. So let's put it up to full speed. So we're going to do a turn like so. But what we're going to say is when the animation is complete, which is something we've been doing down here. And the animation is complete, then run the code that's in player turn left. And now we do the same for turning right. And we move this stuff down here. We change this to idle. So the moment this is picking up walk state changes, so maybe we do actually want this to be on run. Because what this is also going to do is if you're not running, then both of them are on 0. Then if you go to walk, it's going to do the turn. So we need to know previous facing. So I'm going to set this to 0. And what that means is it's going to actually no, I'm going to set it to this. Actually, I'll set it to 0 there, but then we'll set this here. And this is just going to make sure that whenever we face a certain direction, it can use this to work out whether or not we actually do need to turn or not. So here we know that the walking state has changed, but what we now need to know is has it changed to be different from the player last facing direction? If that is the case, and it is different, then we're going to jump to here. So if that is not equal, we jump to here and we do that. Otherwise, what we're going to do is we're going to immediately jump into the left turn. In other words, well, actually, do we even need to do that? No. But we will put, if we change that to run. Yeah, okay. Yeah, okay, that will work. So what that's doing is checking, are we facing the same direction as we were before? Otherwise, if we are, then we just go ahead and run the run animation. Otherwise, we need to do the turn animation first. So I need to do this same thing here for this one, like so. This will be turn right. And then the other thing I need to do here is I also need to jump straight to this skip again. Okay, so now we are turning properly, we are walking properly, and these routines should be making sure the right animation runs at the right time. Right. So now what happens if we're walking and we stop? Oh, first of all, we need to set this plus layer player last. Blah, 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 blah. Okay, so if it's not the same, then we need to do this. We need to store it so that we can store the animation direction so we know next time we turn, we're going the other way. Actually, let's just try that out. I think that might be enough for now. Let's give that a go. We've got about half an hour left, so. Oh, not null Bulgaria. Oh, not null. That has to be. I have to put that in there. Not null. That's a great reference there to the what's the episode backwards, isn't it? I know, Red Dwarf. Good reference. I like it. Okay, Summit is not loading. Relative stuff is illegal, too far. Line 113 in control. Okay. So long branch there. It's probably enough. It's the only problem when you start using macros all over the place like this. It's very easy to run out of a relative address branch space without realizing. Like again, there you go. 1, 2, 3. 1, 2, 3 is that one there. Yeah, so we need to know which way we were facing, even if we're not walking. So even though we've got a flag which says we're walking left and we're walking right, we also need to know which way we're facing. See, there's a problem there. Uh, I'm going to slow down the animations actually because I'm not entirely sure what's going on, but yeah, there's something wrong there. But you can see it is doing a turn animation. So let's go and take a closer look. Okay, so first of all, let's slow everything down. Let's slow the turn down. Idle doesn't need slowing down. Let's turn the run down. Okay. Play a turn left, play a turn right. Okay, so if we're facing, oh, okay, we also need to set the new face direction as well. So if we were walking left, we need to set the new. Oh, hang on, we are setting new walk state. So wait, is that taking the new state? Is that triggering? That should not be triggering every time, or is the idle is triggering? That's why. No, it's not. It should be coming to here. Okay. If I pull in one direction, it shouldn't. It should only be doing this skip here and nothing else. Let's check that. Okay, so take our current state, compare it to our previous state. If they're not the same, then go to here. Take our previous state. And take that. Yeah. So take our previous state just the walking left and right. Actually should. Just compare what? Okay, so then take our current state, and if they're not the same, come to here. Otherwise, we skip the entire lot. Where do we store a move state? Previous move state. Take our player move state, store it in previous move state. Okay. So at the moment I'm trying to walk right. So what's happening? So it comes into this section once because player walking right is only set. Actually, can I store? Let's store player move state in the debug panel. This is why we have the debug panel down at the bottom. Can't remember how to use it at all, so we'll just have to go and take a look around some code, probably around collision, I guess. Debug. No, I was hoping to find the word debug panel in here, or panel. No, or print hex. I mean, that'll do. Okay, yeah, that's fine. All right, we'll do that. Isengard, I've not heard this for a while. So we'll do it here, I think. Here. Actually, if I do it, yeah, I'll do it here as a full debug section, so I can just remove it. So let me just wrap it in these. Print hex, and then I give it a string. So I'm going to put a PM, and then a position, which I'll do 8 or something. There we go. And then, for God's sake. Three, 4, 5, 13, 16. So I do 16 there. I'm not sure how many spaces I've got in there, but let's try. Let's lower it down a bit. Actually, let's do. Oh, actually, just do. Move and previous. There we go. So P. That should easily fit. All right. So now we should see these at the bottom. Hopefully, I can't remember how many characters we fit across these. I think it's 24, but I can't remember at all. But now we should be able to see the player previous and current state, which will give me an idea if something is going wrong at the top. But I'm definitely able to chain some of these together, which is good. The fact that we can actually chain events together is a huge boost to the animation system now. So yeah, I mean, it's showing completely the wrong values here, but okay, whatever. Okay, yeah, so you can see there is indeed something odd going on here. So the player move state is the first one. So this 0, 0, and it's kind of flicking between a few different values. I'm not sure where it's getting that B2 from at all. But that's what we're seeing there. Walking right, that kind of makes sense. That way, I'm not seeing any sense whatsoever. But B2, okay, that kind of makes some sense. But I don't know where the B is coming from here. And also, it's flashing on and off all the time, which makes me wonder what's going on here. Okay. So we should be taking our move state and passing it directly to the previous move state, which is the B2. So we've got 0, 0 and B2. And then take 0 and put it in player move state, which we're doing. So then all this runs, which does nothing until we get down to here, because I'm not controlling anything. I'm not doing anything that would change any of these values. So we get to this point, at which point it tries to print these values out, and what we end up with is two very different values, 0, 0 and B2. They should be the same. I don't even know where the B2 is coming from. So that's interesting. Okay, so this is check if player move state has changed. Okay, so this is right. Let's move that up there because this is exiting if they haven't changed. So let's just run to see, because that's why it's not displaying the same on the screen. But now we should get the same value on each side. So I've only had 3 cans of cider all night. I feel quite wimpy. I've normally had that plus a bottle of wine. It's gone pretty quick tonight as well, actually. Okay, so there we go. We've got the values matching now. Okay, so that's good. The question is why we got B2 there instead of what should just be 0, 2, I imagine. So that would need to be lowercase m, lowercase p. So our move state and our previous move state. So only if they're different, which is only going to happen once until you start moving, and then they're going to remain the same. But you can see, look, they flicker around between two values. I think the values are 0 and B2, but they are still nevertheless flickering between the two. Let's get rid of the turning thing. Let's get rid of that, see if that's affecting it. Every girl loves the Dickens. So much fun. What are you on about? I'm going to code faster. Are you sure about that? Yakety sax. Oh, I see. I see what you're saying. I see. I see. I see. It's not going to speed me up. Okay, so that hasn't changed anything, but the animation is not flickering about now. Oh, actually, but you see what happened now. The turn animation is, we're still moving as we're turning, so that's why we need that extra check in here to prevent that from happening. But maybe this is the wrong way around. Let's try switching this. Like that instead. I mean, I can't see that having any effect on it, but right at this moment in time, I'm trying anything. So I'm getting to the end of the stream now. I'm getting desperate. Oh, who won the music compo, by the way? I listened to all of that and bloody missed the results in the transmission thing. It was between two for me. It was the Jason Page one, 13th, I think it was called, and Jammer's Drummage. The drum and bass. That drum and bass one was incredible. It sounded like some proper dark step drum and bass, which I didn't think the C64 was capable of, but apparently it is. But yeah, Jason Page's was bloody good as well. So Um, yeah, I don't know which one won it though, so it'd be good to know which one was the winner. I wouldn't over queue too many tunes. I'm going to be finishing in 10 or 15 minutes or so. Okay, so there is definitely a problem with the turning being turned on and off. So could it be that okay, let's have a look at this. So if we're turning, then that PM state needs to be turned on. Otherwise it needs to be turned off at this location. Okay, so whenever we've finished, we need to turn that state off. So that would be reset bit in player move state. Otherwise, if we are turning, we need to set that bit. So that's what we need to do here. However, that bit is also cleared every frame. So we need to make sure that that isn't cleared every frame. And that's because what we're doing is we're just resetting the player move state to 0 up here. But instead of setting it to 0, what we should be doing is turning off the things that we don't want. So instead, what we're going to do here is we're going to reset those bits, and those bits are going to be it does make me want to bobble my head around. It's those bits there. Okay, I think that might actually solve our issues there. Then I think the only thing we've got is the only thing we really need to do is get the exact kind of directional things working out. So okay, neither of them are working now. And that's probably because our initial state is set to FF, which says we are turning. So instead of FF, what I'm going to set is I'm going to set zeros as our initial state. It's going to take a little bit of playing around to get this right, but I think that the system is kind of there now. What I want to do though is I want to look at this controls and try and work out what can we abstract out of this. Can we create kind of animation schemes for a player control? Yeah, see, look, I can't do anything here now. We've still got FC in the yeah. Okay, there's some odd stuff going on here. Where's it getting a FF from now? It should be 0. Thomas the Tank Engine. Yeah, I don't know. I don't know where it's getting these really high values for the player state. It should not be doing that. Don't know why I'm humming along. Oh, that was short. Actually, I was worried that you were putting too many songs in Wallet. That was incredibly short. Yeah, and then it gets. Oh, and if we're in idle, then this needs to be turned off, maybe? Is it because we're in a turning state? No, look, FC again down there. What is that about? Something is going on weird with the player states for some reason. Might be one for next time, this. Yeah, they were very quick. I'm not even going to open my fourth cider. Don't really feel like it. Oh. So in case anyone wonders why I keep looking to the side, that's where my TV is with the thing on. Okay. Seems like we're back to square one again with this. Hmm. I am not entirely sure what to do. Just trying to think how that's actually working. Damn, this is tricky because yeah, my brain's not working this out for some reason. Right. So our default state is we're doing none of this. So we're idle. Our last facing direction was right. That's kind of irrelevant at the moment. Walking left and walking right, we just reset those bits. That's all we're doing. And we store our move state into previous move state. So we just turn these off until we can work out if we're still doing that or not. This doesn't matter, the vertical movement. The left and right does matter, however. Oh, boom. Oh, that would have been a good. I reckon that was a 10-pointer if anyone had spotted that, because that must have been there a long time. But you snooze, you lose, as the playground saying goes. It explains why it's FC as well instead of 00. Shows why we're getting weird numbers. So now hopefully we'll see 00 at the bottom instead of FC. No, I noticed that because we're all looking at the dog. Hey, doggo. No, is that just instantly jumping? I think it is, isn't it? But now we're getting the right things. So but the turn animation's not happening. At least I don't think it is. Let me let's take a look. Okay, so if the walk state is changed, yeah, it mustn't be working because it would pause otherwise. Okay, so we if we are walking right, no. If we're walking left, and that's not the direction we were facing in. Oh, okay, maybe this is wrong. Maybe this should be equals. Was that? Oh god, I sat waiting for it to load and it hasn't even started. Okay, let's try again. No, see now we're stuck in this. It's so close. It's just the turn animation isn't working for some reason. Uh, so our walk state has changed. So let's say we're walking right and we want to turn to walk left. So we take our previous move state, which is that we were walking right, and our new move state, which now says that we're walking left. We weren't turning, so this was not triggered. So we pull to the left, and we actually end up setting the state as walking left. So we were walking right, now we're walking left. So this comparison here brings us to here. So now we compare our current movement, which is walking left indeed. So we jump to here. Our last face direction is different. So we are not so we jump to this one. We don't do this one. So we store the fact that we're now walking left into player last face direction. We set the player turning, and we call this, which for some reason is immediately exiting here. So let me just get rid of that, and let me get rid of that, and see if these turn animations are triggering at all. Maybe they're just not triggering. 1, 2, 4. Yeah, it's self mod. No, those turn animations are not triggering at all. Which would imply this is not, we're not even getting to this point. Which means this is triggering instead, right? Because this is the only way we can change the animation is by jumping into this. Self mod, yes, but immediate mode. That's what I want, though. I want immediate mode. That's exactly right. That's exactly what I want. So this is the problem, that for some reason this is triggering, because this is. I mean, if I get rid of that and do the same on here. Oh no, because that. Hang on. I'd have to get rid of that. Let me just get rid of that for a second. So this is the immediate turn. Getting rid of that and replacing it with an actual turn. Does mean, however, if I press left, stop, and then press left again, it's going to do the turn. But it will show me that that is not working properly. It could be just the player last face direction is not right, in which case I can kind of trace that out and see what's happening in the code. So not running. You sure it's not a compare? What? It is immediate. That's exactly what I'm using. I'm using compare immediate. Look, immediate. The only reason this is a 16-bit number is to remind me it's a self mod. Internally, it's just going to do that. Have you been on the brandy tonight? Have you been drinking? Ah, okay. You can't see. Okay. No, it is there. All right, is it tired? Yeah, I'm getting tired as well. Actually, it's yeah. See, look, there's something really odd going on. I need to I need to take a proper look at this at some point. I don't think now. I don't think I have the time. I'm going to be finished very very soon. So I'm not gonna be able to work this out right now. But it's kind of almost there. We kind of had it working. But I think I'm gonna leave it there for tonight. It's a relatively quiet night tonight. Anyway, let's see if we can find who's streaming. My God, where's my raid panel? God. And we'll give this a try next week. So we will be doing this every weekend now. So I might do. I need to figure out actually when to do the game conversion streams because I do want to keep on doing this as well. But I would like to get some games converted as well. So I'll have a think about it. So Toxic Frenzy will be next week. Yep. Got it. Yep. Toxic Frenzy next week. Um, and then I'll work out where we can go from there on this. I may try and fix this animation in my off time. I think we'll raid Duke Donuts. He's on. What's he playing? It's a comic game. What is that? That's interesting. Yeah, I'm not sure. Let's go and raid him anyway. It's always good to say hey to Duke. So yeah, we'll go and raid Duke now. Thanks for coming along tonight, guys. Hopefully you got some use out of the very kind of quick and dirty kind of talk through how Luma works. And well, as I say, we'll go through that again when we do the next game conversion, and I shall see you all on Thursday. Now I'm going to take Tuesday off. I'm going to, as soon as the Game Boy game is finished now, I'm just going to relax, going to have a Tuesday where I do nothing. And I'll see you all on Thursday for Checknoid. So take care, guys. Thank you for coming. Thanks for all the bits. Thank you for joining me, and I'll see you on Thursday. Cheerio.